2017. Presently, he is an assistant professor in electronics and communication engineering discipline IIIT Naya Raipur. He has published several articles in journals and conference proceedings to international repute. His research interest is in electromagnetic RF and microwave communication. Over to you, sir.
Thank you, Onupa ma'am. Thank you, Dr. Mandal sir, for giving me such a nice opportunity. So without wasting time, so let me share today's content. So I don't know whether my slide is clearly visible to all of you or not. So just for confirmation, may I know whether my slide is completely visible or not?
Yes, sir. Visible.
Yes, sir, visual.
Okay, thank you. Okay, so once again, thank you everyone and good morning to all of you. So this is my brief introduction. As all of you are aware with my departments and as well as my institute. So this is a very new institute. Chhattisgarh. I will focus on these many topics. First of all, the introductory part, then design of single band bandpass filter, then wideband and ultra wideband bandpass filter. So take a break. Then later on, the discussion will be going on related to design of multi-band bandpass filter. Then summary and conclusion and some selected reference we'll see. So I hope most of we are aware with the wireless communication system, right? So the front end, whatever we used to deal with, so front end is consist of basically antenna. Just after antenna, the very means interesting thing would give the proper what is actually signal, right? So we do use filters, especially band pass filters. So whatever the communication system it is, so if the communication system will be wireless, so definitely there should be band pass filter just after antenna, because we know antenna cannot give the means the all kinds of requirements, right? So to fulfill all those things, so altogether we do need filter, right? So there are so many advantages. So after the advancement of recent technologies, say for example SIW, substrate integrated waveguide, then LTCC, low power means those are kind of ceramic technology, right? So those means we used to fabricate in very high temperature environment. So after the advancement of all these things, so the filters means what is actually implementation are quite simple commonly based communication systems. So therefore, we can imagine very easily the what is actually cost as well as the weight of all those things. Right now, whatever the electronics gadget we do use, so we can imagine what is the weight right now and what was the weight just before 5 years, 10 years back, right? So if we go back to 2G and GSM, then 1.5G like that, right? So this is at a glance, you can say my whole thing, what I did during my research time, right? So whatever the thing we used to design, it has to be satisfy certain constraints, right? So here, although in my slide, I did not mention that much. The thing is that whatever the device, say for example, this is antenna, ultra wideband antenna, normally we do prefer for kind of testing. So this is a very teeny tiny structure, as you can, this is what the filter is, right? And it is kind of specific filter. This is basically ultra wideband bandpass filter. So this filter has to operate in a very satisfactory within the stipulated band, whatever we do means design, right? Whatever the means application is, it may be satellite communication, it may be for radar communication, it may be for what is actually high precision data transfer kind of thing, right? So what is required for this particular case? So two generator is required. So obviously a network analyzer can also be act as signal generator, and this is normal signal generator what we used to have in our lab, right? And one spectrum analyzer to see the satisfactory result. However, I am not focusing more on this. So this is just a glimpse apart from the design part I did. Okay, so to give you all the what is actually flavor of bandpass filter, right? So here all of we used to see dish antenna or LNB, LNA kind of thing. So whatever, if we consider this box, right, LNB, so what we can see, if we uncover it, right, apart from the antenna part, so this side kind of conical, what is really cylindrical kind of thing, tapered cylindrical kind of thing we can see. So this is so this antenna part has been feeded. So if we uncover it, so we can have the flavor like this. So this is basically circularly polarized antenna. Normally we used to take care, right? So apart from this, so there will be so many number of components or the portion we can say. So this is the whole communication what a setup we can say in a word, right? So if we observe very carefully upside and downside, so we can see, so there are so many things, right? So if we concentrate now on this particular portion, this is what filter, what we normally call this, right? So this part, so now the challenge, if we consider, so for this particular communication, so this is the space we are being provided, right? Apart from this, there will be so means LNA part, their mixer part, there will be a signal processing part, right? So many things will be there. But consider the criteria. So as an engineer, so if this is the only space for designing bandpass filter, whatever the filter it is, it has to be fitted into that particular area only. So therefore, there is a huge challenge in today's world. So day by day, electronics gadgets size are going to be reduced drastically. So therefore, whenever we will be designing, we have to keep that in mind. What is the area has been provided specifically for means so therefore, design and design is the only thing to get success in that particular field. So normally, whenever we used to think about design of any kind of circuitry, or say for example bandpass filter, so first thing what comes into our mind is ring resonator, right? So it is very basic even in antenna designing also. So from ring resonator we used to start. Why? Because in ring resonator circuitry, so very means limited time we have to think about the what is actually 50 ohm transmitter, means 50 ohm matching, right? So it will match very means efficiently if we consider ring resonator. However, I'm not going into that part. The thing is that ring resonator, if we consider, right? Now, depending upon the what we do want, means what is the challenge has been given to us, right? So obviously for bandpass filter designing, the insertion loss has to be very less, almost near to 0 dB. That means there should not be any kind of loss. Why? Because already in the front end we do have antenna. So antenna, whatever the antenna will be receiving the signal, that signal has to be processed properly. Now, if the bandpass filter will not be so efficient, so almost some portion will be lost, isn't it? So already there is a loss, 50% loss we are considering, because means in wireless technology, if we consider satellite communication, right? So we do use circularly polarized antenna. That means efficiency is already 50%. Therefore, if we have more loss in the bandpass filter side, so what will happen? You can imagine, isn't it? So therefore, for very good bandpass filter design, normally we used to have very low insertion loss. And obviously, if we go through the literature, so literature after literature, we'll be seeing that in most of the cases, so it is almost in 10 to 0 dB onwards. Otherwise, 0.5 dB, then 1.5 dB is also means acceptable in some communication systems, right? So therefore, the choice of material plays very important role over there. Say, for example, normally people do prefer for 3 gigahertz designing for the sake of simplicity, because every calculation will be very straightforward, right? So the RTD red substrate is considered as a good candidate for that. So normally we do not prefer FR for substrate, because in FR for there will be loss. So for filter design, one thing to remember is that the substrate has to be lossless, not lossy, right? And if the dielectric constant will be more, so that is also good. But the dielectric constant may vary from 2.2 to 10.2, whatever we do want. So for this case, this is very commercially available. What is actually a substrate RT Duret 6010. So which is having almost 50 mil. So if we convert it into millimeter, so it will comes around 1.27 millimeter, and the dielectric constant for this is 10.2. Obviously, another thing that is loss tangent, right? Which plays very important role. So if the loss tangent will be very less, therefore automatically inherent nature we can consider, the inherent nature of the substrate will give very less amount of insertion loss. So in this particular case, this is very specific, that is 0031. And for the circuit design, as we know, the inner radius and outer radius. So combinedly, if we consider the mean radius, so mean radius has to be 2 pi r. So as this is closed circuit, so always it has to be lambda g, right? And otherwise, the circuit will be open circuit kind of thing. Then the length has to be lambda g by 2. So this is the kind of basic we should know, right? So whenever there will be closed loop, that means ring resonator kind of thing, the guided wavelength has to be lambda g. And if that will be open circuit kind of thing, that means if only single line, if we will be considering that time, that has to be lambda g by 2, right? So from the transmission line concept, this used to comes into our mind, right? Now, if this circumference will be that much, right? Now, depending upon that, so guided wavelength, so from guided wavelength, so means if we correlate, so for 3 gigahertz, what should be the guided wavelength? Accordingly, we can fit it into this. Now, obviously, there will be so many parameters like effective dielectric constant will also comes into play. So that calculation will come into our very basic calculation, that is lambda g should be uh, equals to what? Lambda upon root over of omega epsilon. That's all, right? Now, whenever there will be a resonator, so it will try to resonate. So, for band pass filter, as we know, the basic is, so at least we have to work with two scattering parameter, that is S11 and S21. So S11 will signify what? How much the signal is flowing from one port to another port. Say for example, this is a 50 ohm line. If we feed any signal over here, so that signal so should come this side, that is port 2 side. Now, depending upon this structure, so there will be flow of a signal, that means there will be distribution of current. So depending upon the current and distribution, how much amount of signal will be appearing this side, so that thing can be analyzed in terms of scattering parameter, right? So as this S11 will come deeper and deeper, right, minus 10 dB, minus 20 dB, minus 30 dB, so that will be treated as a good behavior, right? And parallelly, this S21 has also be touch this zero line, 0 dB line, right? But ideally it is okay, but practically it will not touch. Therefore, there will be some kind of loss, and that loss is known as insertion loss, right? And the tolerable range we have already considered. Now, the thing is that whenever we will be designing ring resonator, so obviously it will be having some kind of harmonics, right? So now the thing is that if we want to design for a particular frequency, that time we have to take care about, means up to much frequency range, we will not allow any kind of harmonics, right? So therefore, the harmonic reduction technique we have to apply. Now, sorry. So the thing is that we can introduce extra thing in the resonator, and that extra thing may be in terms of stop. Now, depending upon the structure of stop, so we used to call in different name. Say, for example, this is similar to T, so that's why we do use the concept that is T stop, right? And we can vary some kind of parameter. Now, this parameter variation. So for this parameter variation, no need to do that much of rigorous calculation. Just kind of hit and trial method also we can do, right? So what it will do, basically, it will load some impedance. So because of that loading impedance, the bandwidth, right? So earlier what it was, earlier this is our bandwidth if we consider minus 3 dB this point and that point to cutting point. So imagine what is the bandwidth right now. Now if we want to fulfill into some kind of systems, so it should require more bandwidth. So to get more bandwidth, so we can do the analysis of stop concept, right? So here, as you can see, for different variation, means variation of W4, right? So earlier W4 was 1.5 mm, and in between, means if we vary from 0.5 to 2.5 onwards, so we can see the, because of this variation, the band is going to be enhanced. Now, obviously, always we have to keep that in mind, that this level always has to be below 20 dB onwards, right? So that in the fabrication part, we can have the means we can have the what is actually constant, means some tolerable range, right? So likewise, we can vary some parameter, say for example C. Now, after fine tuning, say for example, we have fixed all the values for this T stuff. Say for example, here everything has been given, just like C value is 5.3 mm, D value is 4 mm, G1, that is the gap between ring resonator and the feed line here, right? So 0.1 mm, then G2 is 1.2 mm, R1 is 5.9, R2 is 6.9 mm, and the electrical length theta 90 degree, means this arc has been fixed in such a way that, so it means this gap, right? This gap has been considered in such a way that it will give 90 degree, right? So that will comes from theta equals to beta L's formula, right? So if we consider the physical distance, so likewise we can get, so for 90 degree, what should be the length. However, so after doing all these things, what we can see is that although we have started with 3 gigahertz, so because of this loading effect, so although we are getting bandwidth, but right hand side, so but right hand side, what we are getting? this thing. That means the replica of this uh, what is a frequency response, we can say, and it will continue. So means even number or odd number of this resonating frequency. Now this is the thing we have to reduce. For reducing, what we can do, we can add some kind of concept, that is defected ground structure, the DGS, right? So before doing that, if we want to fine tune this insertion loss, right? So to do that, again we can give kind of extra load. So here extra load has been provided and become obtained, right? Now to reduce this one, as you can see, the back side, that means the background side, ground side of this structure. So we can implement kind of defected ground structure, and as it is showing kind of H type or dumbbell kind of shape, we can say. So we can name it as a dumbbell shape DGS kind of thing. So what basically it will do, the ground, this defected ground structure will give kind of stop band response, right? Now to do this analysis itself, what we have to do, first of all, just we have to consider 50 ohm transmission line, and beneath, means below of that, so we can east out this much portion, and both side the structure has to be similar. That means the mirror image has to be same, right? So now depending upon the number of these defected ground structure, the resonating frequency will be same, but because of the number of defected ground structure, what it will happen, the amount of this suppression stop band will fall down and down and down like that, isn't it? So therefore in the response itself we can see, earlier this was the difficulties we were facing, and sometimes we used to call it by this term, that is spurious frequency, right? This spurious frequency is now eliminated by this defected ground structure. Therefore in the final design, if we observe, right, below 20 dB there is no edge to edge and the return loss, if we consider more than 20 dB we are getting, and insertion loss, see here, 0.5 dB, and fractional bandwidth, 3 dB fractional bandwidth is 13.8% has been achieved, and the sharpness factor in the stop band here, sharpness factor if we consider, so it will be dB per gigahertz, the unit should be, right? So it has been achieved 160, and from 3.64 gigahertz to 7 gigahertz stop band, so it is showing more than 20 dB. So this is quite means good. So and the another thing is that whenever, so all the references will not be available in this slide, so whenever we used to design, we have to see so how satisfactory our structure is behaving, right? So therefore with the recent literature always we have to compare. So what is the advantage? What is the disadvantage? So every time it will not be providing advantage in all terms, but in some of the cases it has to provide. So therefore, as you can see in terms of size, in terms of 3 fractional bandwidth, then TZS, that means transmission zeros, right? How many transmission? If the number of transmission zeros will be more, that means that will be considered good kind of filter. So these are the things. Next, to do the susceptibility study, that means if there will be some kind of a radiating element, right? So whether that radiating element can degrade the performance of the filter or not. So to do that, we do kind of study that is known as susceptibility study. To do that, what we used to do basically, so if this will be our filter, say for example, in the cross section of the filter. So this will be top side metal. Then in the middle, there will be substrate. And in the down below, if there will be kind of structure, say for example, in our structure, defected ground structure is there. So they are cut plane, you will be having, there will be some kind of metal and there will be non-metallic portion, right? Now, the thing is that whenever we used to excite this filter, means we will be giving the signal, say for example the signal generator 2, right? And if we sense the signal into spectrum analyzer, so whenever there will be no any kind of obstruction or signal, say for example extra signal, so say for example here the patch antenna has been considered as a disturbing element, right? So if in this particular antenna there will be no signal, so we can assume that there should not be any kind of degradation into the performance of this filter, right? And whenever there will be signal into the antenna, so there should be degradation. But the thing is that depending upon the close proximity, so if it will be very close proximity, that time it may degrade its performance. But the thing is that what is the space available to us? So if you have seen the earlier slide where we have explained the physical realization of bandpass filter. So surrounding that, there should be some kind of space, and that space is more than 10 mm we can consider, right? So within 10 mm distance between the structure and the antenna, so whether degradation is going to happen or not. So we can see, so from this graph, right? So if we consider the relative power and the distance, more or less we can consider there is no effect of radiation at all if we consider even very close proximity, 10 mm distance, right? So in the far field region, so obviously there will be no question of degradation, but in the near field region there may be possibility. But if you design the filter very carefully, so there will not be any kind of performance degradation. Okay, so that was about the ring resonator, basic ring resonator. Now if we want the dual bond behavior of ring resonator, most of the literature, so normally we do prefer, so this was the literature from where we used to get the concept, that is means fluctuation of mode, right? Appears means how we used to calculate the fluctuation of mode, that means how we can distinguish between even mode and odd mode. So the paper said that if the circular symmetrical ring resonator will be used with collinear feed lines, then only one of the mode will be excited. So this paper showed that if the coupling lines are arranged asymmetrically, then the mode, both mode should be excited. That means even mode and odd mode, right? So otherwise, another way of exciting the two degenerate mode is to disturb the symmetry of the ring resonator. That means what? The two possibility will be there. If we arrange the feed line in certain angle, another way, if we give any kind of obstacle or disturbance into the ring resonator. So two possibility. So same thing here also we have done to get the even and odd mode analysis. And one thing to remember here is that this is not very simple to get this response, right? Whenever we will be doing the dual mode behavior, one thing we have to keep that in mind, that the feed line, that means the feeding structure and the resonator has to be far away, as far means as far as possible, right? If that will be close proximity, that means strong coupling will be there. In strong coupling, it is very difficult to find even mode and odd mode, because both will be superimposed with each other. So therefore, we do prefer weak coupling whenever we will be doing dual mode behavior, right? So for dual mode characteristics, this is the thing. So what we have to do, say for example, this is the structure. So this is our feed line. So this is, if we consider this is port 1, if we consider this is port 2, and this is another feed line. If we vary this gap G1, right, up to certain extent, so gradually what we can see that instead of giving this one peak, so gradually it will separated out into two spike. So earlier it will be only spike, just considered S21, right? And gradually, if the weak coupling will be there, so automatically there will be deviation spike. So from this one to this side. Now, here the value, that is this, has been observed, means the variation of L has been observed. Now, whenever the variation is being from 1 mm to 4 mm, you can understand. So ring resonator is fixed. That means the outer periphery is is fixed. But the thing is that in that range itself, so if we want to give two signal, so it will send the signal very satisfactory. That means what? Frequency is same, but two different mode. So at a time, so means what is actually two-in-one kind of work can be done. So this is the advantage of dual mode resonator, right? So now instead of using single stuff, means the uniform stuff, so we can make it the taper kind of stuff, and we can do the analysis. So after doing this analysis, what we can get is that we will be varying the W, then the odd mode and even mode will be separated out from this frequency. So at 5.3 gigahertz, sorry, means if the W value is 0.8, right? So there at 5.3 gigahertz, so we are getting both mode are superimposed. Now, gradually, if we move on further and further, so we can have, so for different frequency we'll be having even mode as well as odd mode. Likewise, if we vary the D, so we can get this scenario, right? Now the interesting thing is that earlier, in earlier case, this was the single, right? Say for example, so only single band mode is also single. That means even an odd mode was superimposed. So that's why it can operate into single mode only. But right now, this is the frequency is same. But if we want even mode, so we can give the signal considering even mode, and if we want odd mode, so at a time, two mode we can get in the same frequency. That means no need to enhance the structure itself. So in this structure itself, so two kind of nature we can get. And the interesting thing for here is that in earlier case, in simple ring resonator, we used to get only one transmission zero. One transmission zero is what? Whenever we used to get the spike of H21, right, left hand side and right hand side. side of the passband. So this is our passband. Left hand side, this is one spike. Right hand side, this is one spike. So tip of these two spikes are known as transmission zeros. Now the here one transmission zero this side, another transmission zero is that side. So what is the result we have achieved over here is 3 dB fractional bandwidth is 5.32 gigahertz. Return loss we can get more than 20 dB. Insertion loss is 5 dB. Point to be noted, 1.5 dB. But here the thing is that the substrate, because of the substrate, we have okay. So we have compared it. So in the first we have seen is the ring resonator. So initially a circularly ring resonator we have considered, and to suppress the harmonics. So what okay. So that was about the single band bandpass filter. Now the challenge is design of wideband and ultra wideband bandpass filter. So this is a very simple structure, normal. To have bandpass filter, what we used to do, we used to take a length, a transmission line of length lambda g by 2, right? And over that, if we place any kind of stub, and that stub length would be lambda g by 4 always, right? Because it is open stub. So and now if we implement it, so what value means thing we can get the same thing, the bandpass filter. Here also bandpass filter nature we can get, isn't it? But the thing is that how to increase the bandwidth. So to do that, what we can do, so for example, this is our final structure, final response for that particular structure. Now if we want to enhance, so we can think about the stub side. We can do kind of tuning in stuff. Now, if we see if the fractional bandwidth is going to increase or decrease, right? So therefore, we can understand that there will be possibility of getting wider bandwidth. So for example, here some value of the stuff has been tuned. So for example, L4 value has been considered 14 to 26. So here, if we are means interested to take any values, and depending upon that we can choose that particular value and we can get the wider bandwidth. So earlier consider this much bandwidth we are getting. Now introducing extra stuff, we are getting wider bandwidth. So to do that, another thing comes to our mind is the external quality factor calculation. So from the external quality equation itself, we can put it right, and this will depend upon the coupling. This will depend upon the strength of coupling. Right? If there will be if there will be strong coupling, so obviously we can have the value of external quality factor, right? So this is how we have achieved the wider bandwidth. See, earlier case, the bandwidth was very less. Now the bandwidth is quite more, and we have achieved the 75% fractional bandwidth in this particular design. Obviously, as this structure has been designed in FR4 substrate, so therefore there is a little bit more insertion loss. Otherwise, everything is quite good, right? Compared to means a sharpness factor in both sides, left hand side and right hand side. Even transmission zeros are also there. So therefore, so it is means and this work shows means from this comparison table itself we can understand so how good the filter is. Okay. So now for ultra wideband filter design, so there are so many ways of designing the filter. Now here what we have considered is by considered achieve the ultra wideband response. So from the response itself, S parameter response itself, if we consider, so this side frequency, this side S parameter means dV value, short a lambda g by 4 distance staff over there, so we can have the resonating frequency accordingly, right? So now if we see, this is the transparent view of the structure. So this mission line and down below there are defected ground structure. What are those? So these are nothing but, so ground side there will be full of metal. From that full of metal, if we eased out certain portion in different shapes, no matter shapes would be exactly similar to this, right? But the thing is that we have to defect means we have to create some kind of disturbance in the transmission line, then only we can have kind of means different response, right? So what it will do, so depending upon the number of defected ground structure, so here is 1, 2, 3, 4, right? Therefore we can have so 4 different peak means there will be harmonics like this, something like this, and considered as a low pass filter design. So what basically we are trying to do is, so this is creating kind of pass band, right? Now this side we are not getting any kind of good response. That means it has to be down below 20 dB, then it has to move up to 20 gigahertz onwards, but this response is not good. So what we are trying to do is we are trying to suppress this thing by incorporating low pass filter. So if we superimpose both structure, right, so it means this structure itself will be showing the low pass filter characteristics, but if we superimpose both, what we are getting, see, we are getting the frequency response have been improved and little bit harmonics means little bit disturbance is there this side. So and the around 18 gigahertz response we can achieve, and the response will be little bit poor. And to superfine this structure, what we can do is that again we can add extra step impedance stuff, right? So we are playing with impedance of transmission line. So if we do that, we can see previously what was the nature of the response and now what is the nature of the response. So previously in-band response, in-band nature was something like this. This was the final, right? If we consider S11 very carefully, and this side the nature was not that much good. But right now, after implementing this step impedance means step impedance stuff, as well as by varying the length, effective length of defected ground structure, and by placing it properly, so we can have ultra wideband bandpass filter nature. So from here what we can see is that frequency response have been improved, right? And this was the fabricated structure, and we can see the 3D fractional bandwidth now we have achieved 121.67% at the center frequency. So central frequency for the ultra-wideband bandpass filter here has been considered 7.15 gigahertz. Passband insertion loss is less than 1.09 dB, including the loss from the bridge to HMI connector. Also, will be providing kind of loss, right? Passband return loss can see better than 15 dB. So this is the simulated result. And the interesting thing is that, so whenever we used to design the ultra wideband bandpass filter, now because of the recent technology, so we have to suppress, means we have to block some part of the ultra wideband filter, right? So what we can do is that to do that, again we can think about extra stuff to incorporate with the whole resonator. So this side, this is metallic stuff. This side is also metallic, obviously step impedance stuff. It is here also step stuff. So the advantage of step impedance stuff is no need to increase the length further and further. So within a very small length itself, so you can fit it, right? So therefore, so earlier was means earlier bandwidth was from here to here. Now if we want to suppress, say for example, if we want this bandwidth itself, then this one and this one, that's all, right? Then we can suppress in between by incorporating those concepts, right? So these are the response. So here two notch has been provided. So to reject 5.8 gigahertz WiMAX frequency. So as we know, the range of WiMAX is 5.15 to 5.825 gigahertz, 6.8 gigahertz RFID, and the range we know 6.9 to 7.2 gigahertz, right? So if we notch it out, then obviously it will work just like multi-band filter. So this is the means one more advantage of ultra wideband filter, means if we create kind of notch in the ultra wideband, it will to some result in terms of S parameter, right? And from comparison table, we can identify, means we can understand what is the performance of it. And obviously, susceptibility study has also shown very good agreement with it. Sorry. Okay. It is 10:51 now. So do we need any kind of break? Otherwise, I will continue with next part. So up till now, whatever we have considered is the single band bandpass filter, then how to get the ultra wideband bandpass filter nature, and in ultra wideband bandpass filter, how to create kind of noise. And if you have any kind of question, you may ask me up to this much, whatever we have discussed. Otherwise, we will proceed further. Any one of you? Okay, I hope there is no question.
Participants, if have you any queries regarding this topic which is already delivered, sir, Dr. Lakhinder Murmu, so please ask, feel free, you can ask if you have any queries.
Hello, sir. Hello,
Yes, yes, please.
sir. You are using, sir, attitude substrate for the filter design instead of FR4, sir. But
Yes, yes.
sir, but now commonly we are using all types of antenna design. Why like this,
See,
sir?
actually for antenna design, na, so for the sake of simplicity, we used to fabricate it for the sake of simplicity. Why? Because of means whenever we used to means launch any kind of satellite, na, so there we do not use that kind of substrate. Otherwise, what to happen means if the performance is the only thing, then we have to move on whatever the substrate is, it no matter whatever the cost should be. right? But if we consider, say, for example, if we are in the institute, right? So the question will be arising. So for Roger substrate 1 feet by 1 feet, it will cost around 20,000 like that. Now, for the researcher point of view, it is very difficult to bear that much amount, right? So better to do the analysis in the lower means what is actually cost material, that is FR4. 1 feet by 1 feet, how much it will cost? 100 rupees. And see all kinds of performance, right? For the final product, we have to think about it. So normally for the final product, we do not use FR4. Otherwise, if we will be using FR4, right? Then all the things has to be into that substrate itself. That means your antenna as well as filter, right? So like that. So otherwise, one by one, then means combine it, no matter. Is that clear?
Okay, sir, clear. But it will be costlier than the FR4.
So that's why, means for research purpose we can use FR4, but for application purpose, so we have to use very costly material. That's all. Otherwise, the signal means performance will be degraded. So if we do not want that much insertion loss, say for example, 2 dB insertion loss is tolerable. No matter, we can use FR4. Even dB insertion loss, even 1 dB insertion loss, if it will be tolerable, so we can go for FR4. But if the performance will be the questionable thing, that means if we want the insertion loss 0.05 dB, then we should not design it using FR4. So obviously we have to go for means good loss tangent, means whatever the substrate will provide good loss tangent, that we should pick. Okay. Thank you. Anything else?
Sir, a dual mode hexagonal loop generator band pass filter, how it is better than a ring generator?
No. That hexagonal itself is a ring resonator, if we consider, right? So hexagonal means if we consider, main thing is it is ring resonator itself. But the thing is that to get the dual mode nature. So for the sake of simplicity, let me consider that if the means if I want electric field orientation, something like this, in that particular frequency. Now, if I want another electric field orientation, something like this. So these are two different signals, isn't it? But two different signals are going in the same frequency. That is dual mode, means just for the sake of simplicity. But for single mode, what will happen? So only unit, means only one kind of electric field nature will be propagating in the same frequency. So what basically it means, in the same frequency we are getting dual nature, means different signal we can send. So that is the speciality of dual mode ring resonator. In ring resonator itself, we can have, means instead ring itself, so we can have dual mode nature. Only thing is that feeding nature. So instead of collinear feed, we have to move with certain angle, right? So then itself, so it will give the two different orthogonal mode will be excited. That's all. It is very interesting.
Okay, sir. Sir,
Okay.
sir, if in a dual mode, we can send two signal in a single frequency. Is it okay, sir?
Exactly. Two different signal.
But they may interfere with each other.
So just no, there will no question of interference. Means orientation always will be something different. Phase shift, always there will be phase shift
Okay, sir.
with
Thank
each
you.
other.
Thank you, sir.
Mm-hmm.
So another question
Okay,
is
thank
coming
you.
from audience side, Dr. Ananna. Sir, what
Yes,
are
please.
the modes you have used to improve the filter performance? Actually, in
Sorry,
chat
what is
box
the
written is
just what are the modes you have used to improve the filter performance? See, to improve filter performance, no need to worry about modes first of all. Whatever the mode we are doing, right? So we'll not bother at all. Only thing is that we will bother about the scattering parameter S11 and S21. So there is nothing to do with that. Means whenever we are exciting, say for example, this is ring resonator, this side port 1, this side port 2. So normally what we used to do, we used to give some ideal mode, say for example, TE10 mode we used to consider. To forget about all those things, whatever the mode it is, how you have excited, so no matter at all. Is that this structure is providing you the satisfactory performance or not? So that will be decided how you are designing the structure. So I don't think means you have to use whether TE10 or TE20 or TM10 or TM20, not like that. Am I clear, ma'am? Is that clear?
sir, another question is rising.
Ananya, ma'am? Yeah. Yes, please.
Sir, how long distance we can receive microwave communication in antenna?
Sorry, how long distance means?
Actually, in chat box, another question is rising. Sir, if you possible, sir, you can see it.
Mhm. Just what are the modes? How long distance we can receive microwave communication in antenna? Okay, okay. Let me give you. Although I'm not the expert of antenna domain, right? We do have. Who is this? Okay, sir. See, we do have this antenna in our home nowadays, right? So those are also kind of microwave antenna we can consider. Now consider now what is the distance between satellite and this antenna? Some 1,000 kilometer, isn't it? Wireless communication, whatever the communication nowadays we are doing, so it is because of microwave communication. Now consider what is the range. So now depending, it's whether we are means considering satellite communication. Now for satellite communication, whether it is geostationary satellite or meostationary satellite. So depending upon that, you can imagine what is the range. And for normal, our handheld means what is actually cell phone. So obviously, what is the distance between BTS tower and our cell phone? 1 kilometer, 2 kilometer, even 500 meter also we can consider. So from few millimeter to 1,000 kilometer we can consider. Few thousand kilometer, whatever the wireless communication right now we are having. Imagine. So that should be the range. Now, obviously, if it will be very far away, so obviously, what will be the performance of the antenna? So it's the kind of questionable thing. So there are means for radar. That's why in for radar system we do use means big parabolic antenna kind of thing. It, am I clear, sir? I hope.
Sir, another question is coming in chat box. How sensitivity
Yes, please.
of a ultra wideband filter can be defined? This is Zahid Ahmed.
Sensitivity. Yeah. See, sensitivity is means everything you can define in terms of scattering parameter itself. Because what is required, no matter how strange the signal it is, right? Even for weak signal also, so what perform between one port to another port. So the things would appear into your mind first of all is, so whether it is means what is the insertion loss of it, what is the passband of it. So that's all. If the insertion loss is less, that means means if the insertion loss is high, that means you can assume the sensitivity is not that much good. That's all. So it is means, see, everything is means with you. So antenna has given you the signal, right? So how that signal is being filtered out, that's all. So already whatever the strength is already there in the front end side. So from that front end side, signal strength is that much only. With that signal itself, you can do the analysis part, right? So it is already 100% signal is there already with you. With that 100% signal, how you are means removing the unwanted signal. That's all the filter means. That's what the filter used to do. So therefore, one thing you can think about in this term. So what see, sir, sensitivity normally in any kind of UWB filter, ultra wideband bandpass filter. So we normally do not show sensitivity. Only thing is that what you can see from here is that S11, S21. If you want more, you can have it phase response, then group delay response. That's all. These are the things normally we used to show in ultra wideband bandpass filter cell. Okay. Like in antenna, we do not use means in antenna so many terms we used to give now, but in filter these are the terms we used to give. So normally we do not give sensitivity separately. Okay, thank you, sir. Now back to all the questions. Okay, right. Okay, so let us move on to the multiband filter design part. Now, with the same structure, means with the same ring resonator, we can move ahead whether it can create multiband response or not. As we know, so this is the ring resonator, right? So this can give us the resonating frequency. Now, if we want to have another resonating frequency, again, if we create some kind of defected ground structure down below of it, and if we arrange properly through the periphery or circumference of this ring resonator, so what thing we can get is that this side, see, this resonating condition is not going to be degraded at all, but this side we can have another band by incorporating defected ground structure. Now, if we super tune, means this fourth structure, defected ground structure, C shape, defected ground structure, as you can see, apart from this band, anywhere we can place another, it is possible to achieve dual band. So therefore here again, F for substrate has for substrate, right? So two central frequency has been obtained. So 2.47 gigahertz. Another one is 5.29 gigahertz with very good selectivity, as you can see, because of this transmission zero between these two pass band, right? some of you are asking for PPT. Don't worry, I will share this PPT with Kalyan sir. So I hope you will be getting this PPT. Means don't worry about it. Okay, definitely I will share this slide. Okay, so now the tolerable insertion loss here has been found 1.3 dB and 1.4 dB respectively, and you can see that 3 dB fractional bandwidth also quite good. So for first band it is 45.59%, and for second band it is 15.33%, and the skirt rate of the dual band bandpass filter is also quite good. Right. Although there is little bit deviation, means because of the see the connector has been used, so all those things will create little bit disturbance. But however, we have got the success, and we have published this work in Progress in Electromagnetic Research Letters, that is Peer L. You can have the paper from there also if some of you are interested. And here also susceptibility study also we have shown. So in this work we have got the dual band nature like this. Okay. Okay, for this one, this is all about susceptibility study for the same structure. Now, the thing is that dual band bandpass filter using quad mode resonator. So this works basically presents the quad mode dual band bandpass filter using shorted stub and open stubs. So only by the stub concept, so we have achieved dual band bandpass filter with multi-mode resonator. So earlier dual mode we have achieved, right? But here the proposed filters simultaneously operates in different modes. So one is Bluetooth mode, another one is WLAN mode. So if you don't mind, please mute your mic. Some of you have unmuted it. Please mute your mic. So that it will be good for me to explain all the things properly, right? So for this case, the filter operates in two different, for Bluetooth, another one is for WLAN. So for Bluetooth, the frequency span has been achieved from 2.4 to 2.485 gigahertz, and for WLAN 5.1 to 5.35 gigahertz band. And this filter has been designed using Roger substrate. Okay, and the specification of the Roger substrate is RO4350, dielectric constant 3.66, and the height 0.762 millimeter, and the loss tangent is 0.004, right? And the specialty of this filter is that due to its compact size, it makes a very good candidate for any kind of future wireless communication, we can say. What is the specialty? So see, this is the structure, right? Structure itself is giving dual band nature. Now, for mathematical analysis, what we have to do is that, first of all, we know how to do the even odd mode analysis, right? So this is our basic structure. Say, for example, this is a ring resonator structure. So we have to segregate into two different sections. So one section will be, imagine a line, means in between from the middle. So if we imagine a line, so it will separate it out into two different parts, and this kind of separation is known as even mode equivalent circuit, we can consider, right? Now from this particular point, point in the common point. If we short it, then from this sorting point to rest of the circuit will be treated as odd mode. So obviously the odd mode physical structure is having less size, and even mode physical structure is having more size. Therefore, this structure will resonate in higher order frequency, means in high frequency, and this structure will resonate in low frequency side, right? Now, so whenever the size, whenever this side, uh, just for a minute, please. So I'm having one phone call. Just a minute.
Hello.
Okay, I'm exercising phone call from my office. Okay, so see, so if we consider admittance, right? So each of this length will be having some kind of admittance depending upon its width, right? So, for example, this LS, so it will be having kind of width. So therefore, the impedance can be considered as YS. This L3 will be having kind of width. So therefore, it will be having admittance of Y3. We can consider this length from here to here L2. So it will be having one admittance, and this length L1, it will having another admittance. Now, we are not considering this two width different. So these two width are almost same, right? So the length L1, if we consider width W1, this width, and length L2, if it will be having the width W2. So these width are same. Therefore, the admittance can be considered. So therefore, we are considering Y1 admittance for L1, L2, for L2 also we are considering Y. Right? This is the only difference. If the width will be different, so we can consider different admittance, right? Now, for odd mode, if we consider, so for odd mode impedance, so input impedance will be nothing but Y1 upon J tan theta, and this theta is now divided into two parts, theta 1 and theta 2, because two things are there, isn't it? Because of this L1 and L2, because of this L1 and L2, the thing is now, that means this L1 and L2 has to be lambda g upon 4. And obviously, these 2n minus 1 term will be there for different mode excitation. Right? If n should be equals to 0, so no mode will be there at all. If n all, at least the n value has to be 1, starts from 1. Right? So if we consider 1, this will be 2 minus 1, that is 1, that means lambda g upon 4 it will be. Right? Therefore, the frequency for this case will be what? Just consider C by F formula. So this will be 2n minus 1 C upon, so F should be C by lambda, right? So in that particular formula, if we put it, so the first odd mode frequency will be nothing but our 2n minus 1 into C upon 4 times L1 plus L2 into square root of effective epsilon. So these things is coming from here itself. So these things we will be incorporating over here. Now, our first even mode accordingly will be nothing but minus j. In terms of impedance, it should be Z0, 10 beta, something like that, right? And in terms of admittance, it will be nothing but minus j y1. Then these all terms will be coming over here. That means ys of y1, 10 theta 1 plus theta 2, and 10 theta s. Means all the contribution of length, all lengths will contribute over here. And this is what we used to get from transmission line calculations equation. Very means small equation. So from that equation, one by one, if we put all those values, we can get something like this. Therefore, what it is saying that this L1 plus L2 plus this LS, this all length should be equals to what? Twice n minus 1 into lambda g by 4. So as we are considering for even mode 1, so therefore, these things can be represented alternatively, means in terms of frequency, if we consider. So for this particular case, the frequency will be nothing but twice n minus 1 upon C upon 4. This 4 will come this side, right? So just we can represent it over here. Likewise, for second odd mode, so for second odd mode, what are the length are responsible? L2 and L3. These L2 and L3, these two only, L2 and L3. This part will not be there, this part will not be there. Likewise, for second even mode, the length will be considered as L2, L3 and LS. L, this is L1, this is L2, this bigger part is for first odd mode. So this circuit, if we segregate into this way, very easily we can understand whatever the calculated even mode, odd mode frequency we are getting, the same thing can be obtained from simulation also. So calculation part is clear. So if we will calculate it, so this odd mode and this odd mode. So this odd mode 1, this is odd mode 2. This is even mode 1, this is even mode 2. Now to identify, right? So this LS, this is a stub, right? Sorted stub. This sorted stub, if we will vary this sorted stub, see the odd mode frequency is not being varying at all. It is fixed. See, only this side and this side, these frequencies are being varied. Go back to the calculation part. Is there any contribution of LS in odd mode? See, for odd mode 1, there is no LS. For odd mode 2, there is no LS. So there is no significance of this stub in odd mode. So therefore, in frequency response also, we are not getting any role. So LS is playing role to bifurcate even mode 1 and even mode 2. So fast even mode is coming because of this structure, means see this length, then this length, and this length. This is even mode 1. For even mode 2, this is the length L3, then L2, then LS. Clear? Likewise, for odd mode, there will not be any contribution of LS, so this part will not be there. Only this length L1 and L2 will be there. And for odd mode 2, this L3 and L2 will be there. So from frequency response also it is coming, and from calculation also we can get both the things. Right? So the passband of the proposed filter are formed by respective even mode or mode resonance frequency. The resonators as well as the open stub in the modified structure are bent and coupled with its pair. These, what it will do, this will minimize the circuit size and will generate the transmission zeros. So this is the very means what is the interesting nature of this particular filter, right? So now for getting the proper band, so anywhere we can vary these lengths, respective lengths. So where do we want? Therefore, in the final optimized values, the different geometric parameters for the proposed dual band bandpass filter are being found, like L1 equals to 6.75 millimeter, W1 equals to 0.6 millimeter, L2 equals to 1.77 millimeter, L3 equals to 17.6 millimeter, W3 equals to 0.6 millimeter, LS equals to 3 millimeter, WS equals to 1.5 millimeter, and this grounding via diameter has been taken as 0.5 for the sake of simplicity, so that the fabrication will be quite easy, right? And the same thing can be understandable if we see the surface current distribution. But during the surface current distribution, the thing that we have to set this scale properly, then only it will be understandable. You can see in some cases, so almost this outer arm of this structure and this inside. So one time it is coming into play, right? In another way, this middle stub is not giving that much of significant role. So like this way we can understand also, so in which particular frequency it is operating. This is another way of getting the confirmation. So which part is radiating for what frequency. Okay. And obviously dispersion analysis is also another important thing. So it is inherent in nature normally for different substrate, right? And it cannot be completely eliminated. So only we can minimize up to certain extent. So to do that, what the thing we used to do is that in practice, the substrate, if the substrate will be thicker, so it results more dispersion, and the general criteria to choose the substrate thickness for a good dispersive characteristics is this range. So if we will be designing our structure into this range, that means the h upon lambda has to be less than 0.05. So and here in our case you can consider it is coming 0.0055. Therefore the resonator has good dispersive characteristic in terms of substrate thickness if we consider, right? And here is the fabricated filter and the response of the filter. So what we can see from this structure as a graph is that the two pass band, one pass band is 2.15 and another pass band is 5.19 gigahertz with 3 dB fractional bandwidth of 40% and 21% has been achieved, right? And the measured insertion loss you can see here, it is less than 0.9 and 1.08 dB. Return loss is quite good, almost 20 dB onwards. However, it is showing more than 14.3 and 17.36 dB. The interesting thing from this structure is that its transmission zeros. See, this pass band, there are two transmission zeros, and just after this pass band, there are once again two transmission zeros. And these are attenuating more than 25 dB. And this has also been published in some of the journals, like journals of circuit systems and computers. So same comparison table has been used over there, right? So all the reference you will not be getting in this slide, but if you need, I can provide you all the references. So again, here also susceptibility test, it shows very good result for susceptibility also. Now, the interesting thing is that we want multi-band response, because nowadays we want multi-band communication systems, isn't it? So it is very difficult to get multi-band response. Now, the same concept we have thoroughly analyzed, and we have achieved up to quad band response, right? So, so for triple band, what we have got for triple band nature. So we have tuned this circuit into 0.9 gigahertz, that is for GSM 900, then 2.1 gigahertz for 3G application, and 3.5 gigahertz for WiMAX application. That means WiMAX 3.5 gigahertz, right? And the filter is designed using stub-loaded resonator like previous case, and it is having a common via hole, and obviously it is being tapped with 50 microstrip transmission line. If we and the substrate is same. The interesting thing here is that instead of four transmission zeros, now we are getting 6 transmission zeros, and the analysis is exactly same. Only thing is that extra things will be appearing. So earlier two things was there, now extra stuffs is going to be increased. Analysis is same. So instead of theta 1, theta 2, now here it is coming theta 1, theta 3, theta 5, like that, depending upon how many number of stuffs we are considering. Okay, so if we are familiar with earlier one, now even mode analysis, even mode, odd mode analysis will be very simple. Otherwise, it will be looking like quite complex. Don't worry. If you can do the analysis of earlier one very precisely, whatever the number of stuff will be increasing, no matter at all. Only thing is that we have to remember from the middle portion, we have to bifurcate it, and whenever will be middle portion will be bifurcating it, so that part will be considered as even mode circuit, and whenever we will be considering from middle point over from here, so that part, that means that particular point we have to sort. Always we have to sort it at that point. That time we will be treating that circuit as odd mode. That's all. That is the only way. After that, if we do one by one, so same thing we will be getting. Only thing what we can get from here is that for first event mode, what are the stub lengths are responsible for second event mode, what are the length responsible for third odd mode, fourth odd mode, like that. See, same analysis has been done. So here, as we are talking about triple band pass filter, right? Therefore, the right hand side already will be what? For odd mode frequency. So here for first resonating condition, so we will be getting odd mode 1. For second band, there will be odd mode 2. For third band, there will be odd mode 3. So always right hand side we will be getting odd mode frequency, and left hand side we will be getting even mode frequency. Now, as we know, there is no contribution. It means even dual band, triple band also. See, whatever the LS value we are varying, Odd mode frequencies are fixed. So peak of the spike, if you consider, so these are fixed. Only thing is that even mode are going to be varied. So this is very interesting to do the even mode, odd mode analysis, right? Like then if you vary different things, say for example, if we will be varying L1, that means only in the first band it is going to be varied, and second and third band it is almost fixed. Now we want to vary second band, so likewise we can keep fixed for a particular structure. That means if we want to fix the frequency, first frequency anywhere else, so depending upon that we can do this analysis. Okay, see, the structure complexity is now been increased. So here the geometrical dimensions as given here. The thing is that interesting thing is that earlier we used to get dual band, now we are getting triple band. See, and the thing is that we have to be very sincere whenever we will be fabricating the structure, right? So these things means gap between this stuff, how much it's depending upon that the transmission zero position will be varied, or the means the deeper the transmission line, the transmission zero will fall down below some extent. As here you can see, so most of the transmission zeros for means in between first band and second band are below almost 40 dB. You can consider transmission zero, one transmission zero will be here, another one will be here. Likewise, second and third, one transmission zero is here, another transmission is here. The separation between two pass band, you can understand what is the means what is the performance of it. It is showing very good performance. In most of the cases, we do not use to get these much means what basically deep downfall of transmission zeros. So this is the specialty of this filter basically. So the three pass band has been achieved here are 0.92, 2.08 and 3.59 gigahertz. Obviously with 3 dB fractional bandwidth, if we consider, we are getting 30.21% for first band, 10.1% for second band and 16.15% for third band respectively. And the insertion loss are also into the acceptable range, and the return loss for successive bands are 27.7 dB, 12.3 dB and 16.2 dB. Because as we have focused more on transmission zeros, so you can have the flavor of transmission zeros. So one is at 1.43 gigahertz, another one is as 1.69 gigahertz, then next one is 2.15 gigahertz, then 2.97 gigahertz, then 4.12 gigahertz, and the last one is 5.19 gigahertz. And the interesting thing is that all the transmission zeros are almost more than 30 dB level. So obviously, until or unless we will be doing the comparison, right? So it is very difficult to understand whether our structure is working satisfactory or not. So here is that means comparison table. From the comparison table itself, it shows the result is very good, right? So again, susceptibility study. So I'm not going details into it. Then the last challenge for our case we have considered, so whether the same thing can be implemented for higher passband creation kind of thing or not, right? So here the quad band bandpass filter has been designed with the same concept is same. See, by creating same concept, so what we have achieved, the frequency means our chosen frequencies were 0.9 gigahertz, 2.3 gigahertz, 3.5 gigahertz, 5.8 gigahertz, which are corresponding to what GSM frequency then 2.3 gigahertz is for LT, then 3.5 gigahertz WiMAX, and 5.8 gigahertz WLAN applications. So the filter has been designed with the same concept. The interesting thing is that instead of having less transmission zero, now as we are considering quad band, so obviously number of transmission zero has to be more. So the number of transmission zero here we have achieved, that is 8. And the even mode and odd mode analysis is similar. Here consider one by one. So all the even and odd mode circuit analysis has been given. See, whenever we are imagining a line, dotted line, so from there, if we separate it out, so that will be responsible for even mode. And if we remove LS1 and if we sort at this particular middle point, right, middle point, then that will be treated as odd mode. So this is for fast resonating frequency. For second resonating frequency, so one by one, we can differentiate out. So which are the length are responsible for even mode 1, odd mode 1, even mode 2, odd mode 2, even mode 3, odd mode 3, even mode 4, odd mode 4. So likewise, we have to separate it out. And obviously, we have to do the simulation part also. Not means this is the calculation how we used to do, right? Now, if we do the even and odd mode, so we can see the frequencies are varying, means in some cases it is being fixed, so whenever we are varying, so in other cases another one is varying. So this is what means how we used to get responses, right? And this is the optimized value, so I'm not going details into it. So the concept is same, but the thing is that implementation is little bit different, that's all. And if we see the nature, see, this is first band, this is second band, this is third band, this is fourth band. And interesting thing is that in all cases, transmission zeros are down below more than the means whatever the pass in the pass band, whatever the S1 or S21 it is showing. So this is the specialty of this particular filter, which we have designed for multiband bandpass filters, right? So from this measured and simulated response, what we can got is that, as you can see, passband we have achieved 0.94, 2.27, 3.55, and 5.6 gigahertz with 3 dB fractional bandwidth. This much 40.38, 15.42, 22.82, and 13.95 respectively. And insertion loss. So as this is multi-band, so there will be so many disturbances. So because of that, in some of the band, so insertion loss is little bit high, but more or less. So this is showing very good multi-band bandpass filter responses. And the specialty of this filter is the number of transmission zeros. Okay, so in summary, what we have seen is that we have seen triple band bandpass filter and multi-band bandpass filter. So in at a glance, so these are the things we have considered. So first of all, we have considered ring resonator, then dual mode, then wide band bandpass filter, then ultra wide band bandpass filter. After that, ultra wide band bandpass filter with its notch characteristics. Then how to get dual band bandpass filter using ring resonator. Then using stub loaded concept, how to get multi-band bandpass filter. So these are some selected references, but I have put it here. Okay. So if you have any question, I hope I have finished before time. So it's 7:42 now. So now, if any one of you have any question, you may ask me. I have
So
completed my
I am
discussion.
requesting to all the participants, please, if have you any queries, so ask to our expert.
I have one question is that most of the filters that sir you have discussed in this PPT is working on the low frequency region, that is beyond within a 6 gigahertz range region. So if I want to design a filter for millimeter wave region, so in that case, what should be the material that I have to select to design so that it can be implemented in an efficient way?
Thank you, sir. This is a very nice question. So, Vivek sir, first of all, whenever you are choosing very high, so in high frequency, so we cannot choose FR4 first of all.
Sir, your voice
Other
is not
material
coming.
we can choose. Just yeah. Am I audible, sir, now?
Yes, sir, audible.
Sir, yes, sir, yes, sir, yes.
Yeah. So yeah. So Vivek sir, first of all, we should not choose FR4 in very high frequency because we are talking about millimeter wave technology, right? So as
Yes, sir.
per my knowledge, we should avoid that one. What we can do is that we can go for LTCC technology, low fire means low temperature co-fired ceramic kind of thing. And nowadays, SIW technology is also designing means in that range also substrate integrated waveguide. So normally Roger substrate will be preferable as per my knowledge. And the thing is that whenever we will be designing in millimeter wave, so obviously circuit size will be very small, right? So during that time, we have to think about our structure should be very small, means very, what is it, simple, not that much complex. Otherwise, what will happen for filter design? Even though very small gap will be there now, so there will be huge amount of coupling. So if we want coupling, then it is okay. But if we don't want, so we have to be very sincere in how we are designing the whole structure. Right. So during that time, millimeter wave technology, always we have to think about very means simple kind of structure. Say, for example, in most of the cases in last means multi-band structure, how I have done. So maybe this kind of thing. Apart from this kind of structure, normally we can consider simple lambda g by 2 means wavelength structure, and we can bend it in some different fashions like zigzag fashions and whatever middle line structure we do use to design, right, sir?
As we move forward in this discussion, in the last you have band filters. So in that quad band filter, that sir you have chosen a dielectric material having a dielectric constant of near about 3 to 4. But in the first half, you
We
have
can choose
designed.
very
You have,
higher dielectric.
hmm, 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 hmm.
So high dielectric constant material may be chosen, sir. High
Yes,
dielectric
sir.
constant may be chosen, no issue. Yeah.
Okay, sir. So we can go for the high dielectric, no? Because lower dielectric will radiate most of the
Exact,
power. Right?
exactly, sir. So lower dielectric material has to be means we should not choose it. So obviously radiation will come to play during that time. So better to avoid all those things. Mm.
Okay, sir. Thank you very much, sir, for the answer. Thank you, sir.
Yeah. Welcome, sir. Welcome.
So, if any more question from participants?
Yeah, I think one request is coming for sharing the PPT.
Yes.
So don't worry, I will be sharing this PPT with Kalyan sir. So sir will be circulating with you all, I think.
Okay, sir, I will circulate it to all the participants.
Yeah, sir.
No problem. So, I think there is no more questions. Uh, One thing I would like to share with you, sir, if we choose the FR4 substrate, so for the high frequency purpose, so there are loss, different type of losses, maybe dielectric losses that will increase. I think at the high frequency applications. So
Exactly, sir. So that's why Vivek sir used to ask the question, especially in millimeter wave technologies. So normally we are avoiding. So if we see the literatures also, so no literatures are coming means with lossy dielectric.
So this upper substrate only it is suitable for the low frequency application.
Low
That's
frequency.
it?
Yes, yes, yes. Up to I think 12 gigahertz we can consider somehow. So, but beyond 12 gigahertz, I don't think this is a good idea to choose FR4. So better to avoid it.
Okay, sir. Thank you very much, sir, for your valuable talk and you sharing your huge research experience with our participants, also with me, sir. We are very thankful to you, sir, for your wonderful lecture. So, thank you from on behalf our NIT Manipur from the Department of Electronics and Communication Engineering. So, thank you, sir. Thank you very much.
Thank you. Thank you everyone for listening me with all the patience.
Okay, thank you, sir.
Thank you. Thank you everyone.
Thank you, sir.
Thank you, ma'am. So I think now may I leave, sir?
Yes, sir, sir, you may leave, sir.
Okay. Thank you.
So,
Thank you everyone.
dear all participants, please stay with us from 11, from 12 p.m. We will start our next session, that is session 2. So, please don't give up. Please stay with us. So, just within 5 minutes, we will be back.
Synergy, HR, Human Process Consulting, Jaipur, to talk on happiness, productivity, and emotional intelligence. Dr. Ashish Johari, Principal Consultant, Synergy, HR, is a former professor of medical human physiology and management in HR area. He is a versatile behavioral training and HR consultant for various corporate business houses and training and development institutions, both government and non-government. He is certified from various national and international level reputed training organizations. Dr. Ashish Johari is a graduate in medicine and holds a PhD in business management specializing in authentic leadership and emotional intelligence and has a total of 20 years of experience, out of which 15 years of exclusive and extensive experience has been in the field of HR and behavioral training and consultancy. Co-author of a book for MBA curriculum of Rajasthan Technical University, he has published several research papers to his credit in reputed journals. He has made his presence felt in the field of training with a gifted ability to connect with people and transforming their life from ordinary to extraordinary by helping them to choose their goals. Dr. Jory is driven by his passion for training and has a desire to serve as many people as possible in various fields. He trains extensively on personal excellence, authentic leadership and team building, emotional intelligence, NLP, positive psychology, etc., and his corporate clients. Over to you, sir.
Thank you. Thank you so very much, Anupa. Is that correct? Do I pronounce
Yes,
your
sir.
name correctly?
Yes, sir. Thank you, sir.
Thank you. Thank you so very much. That was a very generous and a very lovely introduction. I'm so very grateful to you for that. At the very outset, I'd like to start by offering my sincerest thanks to Dr. Kalyan for giving me this opportunity to be interacting with you all. And see, it's always a pleasure coming down and having a word with the faculty members because I myself am a part of this wonderful fraternity of teachers. So for me, it's a great privilege, it's a great pride, it's a great pleasure, of course, whenever I get a chance to come down and have a word and share whatever I have accumulated and learn, of course, from this community. Friends, happy to be here, of course. Happy to be seeing all of you. And may I request those of you who can switch on their videos, it would be great to see your faces. I would love to see your faces. Otherwise, I'll get a impression that I'm talking to a blank screen. Kalyan sir, you are excused. I understand the condition that you are in. So please feel free to switch off if you might want to, whatever you are comfortable with. But with the rest, I can always, look forward to seeing your lovely faces. So those of you who can switch on, it would be great. Okay. It will also tell me whether you are really there at the back of the screen or have you just logged in. Okay, thank you so very much. Wonderful. So, can we quickly have, can you just put it on the chat box which location you are dialing in, you are logging in from? If you can just put in the chat box which location you are logging in from, I'll be grateful to you. So, Payal is from Mumbai, great. Quickly, let me see how quickly Dr. Vivek is from Bengaluru, Divya from Bhopal, Saurav from Haldia, Tamil Nadu, Hosur, Punjab, Azharuddin from Manipur, Imphal. Welcome all. Lingeshwaran from Chennai, Naya Raipur, Chhattisgarh, Subhadra Das from Guwahati, Imphal, Manipur. Okay. Vivek Bhatt is from Uttarakhand. Uttarakhand is huge. Which part of Uttarakhand? Ghaziabad. Okay. UP, huh? Jiva. Karnataka. Okay. Okay. Jiva, welcome. So, welcome. Welcome, everyone. Are there more? MPI Maharashtra. Okay, Chaitanya, welcome. All right. Okay. Okay, Dr. Indra is from MC Hassan, Karnataka. Great. So we have people from the entire India logging in. Wonderful. Wonderful. Welcome.
Sir,
It gives me great pleasure.
sir, our
One thing that
participants,
that
uh,
events like this, yeah.
sir, so more than 140 pesticide institute from in the India, more than 140 pesticide
Okay.
institute. They are all our participants.
Wonderful, wonderful. Congratulations to you all for joining in. It gives me great indeed. One good thing that has everyone. We shall begin, and I believe it is in the fitness of things to share with you a PPT that I have prepared for you. All right, uh, here you are. Okay, if you can see my screen, is my screen
Yes, sir.
visible to you all?
Visible, sir.
Yes, sir, visible.
Yes, thank you, Payal. About 40, 50 yards of we'll be talking about linked with productivity. And of course, one more factor is of vital importance. Our workplace should be a positive environment in which we can thrive. Don't you feel so? And that is where the sense behind this session comes in. Emotions have long been acknowledged as either the ladders we scale or the eggshells on which we walk in our workplace, isn't it? Our success with these tricky balancing acts exerts a huge shaping influence on our personality and self. And these days, there has been a lot of emphasis on developing emotional intelligence in professionals, in students, in kids, in corporate, professionals, and university professors everywhere. There's a lot of talk. As a matter of fact, you know it better than I do. That national education policy, which has been recently launched and is in the phase of getting implemented across all academic institutions, it lays a heavy emphasis on the role EI is going to play. Emotions are everywhere. Our emotions can have huge influence over the emotions of others, our friends, family, colleagues. They are tightly woven into our behavior and our decision making. And even if we are not aware of how this interwoven thing is happening, even then they exert their play. So, friends, today in this session, I'll be taking you through these three factors which have a tremendous impact on our workplace, in our lives, in our professional lives, and our personal lives. And this is the triumvirate that we'll be talking about, as you might be very well aware: um, happiness, productivity, and emotional intelligence. Would you like that? Would you like me to speak about that? Would you be interested? Yes or no?
Yes,
Would you like
yes,
to
sir.
hear more about it?
Yes.
Thank you, Dr. Vivek. Thank you so very much. And thank you, Chaitanya. Tell me one more thing before we, cruise along. Uh, how would you want this session to run? Do you want me to keep talking, keep downloading information? Do you want that, or would you want you to talk? That also can happen. I can do the talking and you listen, or you can do the talking and I listen, or we both do some talking, and that is how it can happen. How would you want that? I'll say is interactive. What about the others? How would you want this session to run? We have about 2 hours time that has been given to us to do be there together. How would you want this?
It should be interactive, both sides. Communication should be both sides.
All right, Dr. Vivek, thank you. People want it to be interactive, but then for interaction to happen, the responsibility is on both of us, isn't it? The responsibility is on both of us. Yes, Ravindran, knowledge sharing will happen. Knowledge sharing, of course, will happen, but the knowledge sharing will not happen unilaterally. See, learning, in particularly in adult learners like all of us are, it is a psychosocial process. It flows two-way. So what happens is I throw some thoughts at you, some insights at you. You apply that to your workplace, to your life. You take out your experience and you share the impact. So when we create that kind of interaction, we create a learning pool, a knowledge pool from which all of us take ideas and insights, and that is what transforms us. So it is easy to say that the session has to be interactive. It is easy to say that it has to be two-way, but then it places a responsibility on our shoulders, all of us, which means that we will commit, that we will have to contribute. Do you commit to that? Do you commit to that, dear friends? Well, I don't hear anyone.
Yes, sir. Yes, sir.
Thank you, Dr. Vivek. You are so supportive. I'm so grateful to you. Dr. Asha says, yes, sir. Okay, wonderful. Wonderful. Friends, please feel free. Please feel free. I am not a teacher. You are not kindergarten students. We are all equals, all of us. We belong to the same fraternity. And thank you, Sarita, for that. That's very kind of you. We have come here to take whatever insights we have developed on our workplace, on our personal life, and put it here in the open. underneath, of course, this topic. That is what my objective is. If I'm able to manifest what is latent inside you, the experience, the wisdom, the knowledge that you carry regarding this topic, I'll consider this session to be successful. That is what my objective is. All right. And I need your help. I need your support. I need your cooperation on that. Secondly, what I would like to ask is, and I usually do this, how would you want, which language would you want me to use? Would you want me to use exclusively Hindi? Would you want me to use exclusively English? Would you want me to use a mixture of both?
English, sir.
Yes,
English?
sir.
Okay. Okay.
English
Yes, sir.
suit.
Okay. Wonderful. Wonderful. Gurminder says a mixture. All right. I can speak English. I can speak Hindi. Punjabi ਚ ਮੈਨੂੰ ਮਾੜੀ ਮੋਟੀ ਆਂਦੀ ਹੈ. If there are Punjabi people out here, I can, try to move towards that. But at any point of time, if you feel that I'm not able to reach out to you, please feel free to reject. Please feel free to unmute yourself and let me know. And I'll be too happy to, take you further. All right, dear friends. Just a quick, although she did a wonderful job, I would like to, won't devote much time. I'll give you a brief overview of what we do. When I say we, I mean Synergy HR. So Synergy HR is a concern. I'm working there as a principal consultant. We are into people development and HR advisory. So we consult with government organization. We do consulting with the non-government organization. We do a lot of consulting with the corporate organizations. We work with IT and ITS sectors, insurance, banking sectors, education management, healthcare, infrastructure development, manufacturing, automobile and development sector. And our area is capacity building. Our area in one line word, what we do is we make people better versions of themselves. Okay. And how do we do that? We employ research on human behavior and create and curate programs on that research and offer it to these organizations, anybody and everybody who might want to take our services. This is a bird's eye view of the clients that we have served, are serving. A client list, you can see people, organizations from different sectors coming in. I'd also like to talk about an initiative that we have launched at our organization. It is a community empowerment initiative of Synergy HR. We call it Siddhamana. Siddhamana is mental health and emotional wellness programs. And we are trying to reach out to the community because mental health and emotional wellness is one area that has received great focus in today's times. So I'd just like to sensitize you on this. If any one of you is looking for any kind of workshops like these at their institutions, please feel free to get in touch with us. These are our not-for-profit initiatives. They come at a very competitive budget. We can discuss about that, and we're too happy. And having said this, let me tell you what happens there. We have 3 sessions in which are centered around handling destructive emotion, on hope, on optimism, positivity, emotional wellness, and each session, 3 sessions are there, and each session is concluded by a mindfulness intervention. That is what Siddhamana is. We'll be happy to take you through. All right, dear friends. So what do you see in front of you? Can you name this instrument? Can any one of you name this instrument? Hello, are you there?
Yes, sir.
You can use the chat box. Can let me know. What is it? Computer and mobile. Is that what this instrument looks like? Saurav says compass. Okay, go further. Observe it.
It is more like alarm clock, sir.
Is it? Is it, Azhar? Does it look like an alarm clock?
Rain gauge.
Rain gauge. Okay. Okay, Saraswati. Go further. Look closely. What do you see written on the dial?
Sir, multimeter.
I'm afraid not. Yes, Sarita, weather related. Yes, of course. Weather checking. Yes, Dr. Asha. Vivek says rain detector. A weather detector. Okay. So it is known as a barometer. A barometer measures the weather. It actually weather detector. Yes, Gurvinder. बिल्कुल ठीक कहा आपने. It is an instrument which is used to measure the weather. It is known as a barometer, but we are not going to talk about barometer. We are Elgin barometer. Yes, yes, you got that right. We are going to talk about a mood barometer since we are talking about emotional intelligence today. So I'll like to measure your mood. All right. So you have to do a very simple exercise. All right. What you will do is stop whatever you are doing for a minute. Pause. Okay. And get in touch with what you are feeling at this moment, right now. For a moment, withdraw your attention from your surroundings. Focus on what you are feeling at the moment now. Get in touch with that. Pick an emoji that best relates to this feeling. Okay. And post it in the chat box along with the word that describes it. I'll wait for your responses. Okay. Thank you, Vivek. Thank you. I think I'll have to stop sharing so that I can see the chat box here. Okay. All right, Azhar. Thank you. Thank you. Sarita, the emoji, not just the word. Emoji and the word. Okay. Accuracy. Okay. 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 Happy. Happy. Thank you, Dr. Vivek. Okay. All right. Thank you. Thank you, Subhadra. Thank you, Tanu. Tired. Hindu is tired. Okay. Tired is not an emotion actually, but I can understand. Happy. Thank you, Achla. Thank you, Manju. Okay. All right. Thank you. Thank you, dear friends. Thank you, dear friends. Thank you so very much. Let me go back. Okay. All right. Now, why did I ask this? Why did I ask this? Why did I ask you to do this activity, this exercise? Our emotions, you wanted to check our moods. And why would I want to do that? Arousal and valence. Oh, God. Thank you, Satnarayan. See, emotions impact our actions. The objective, anxious. Saurabh, why are you feeling anxious? The impact of emotions is on actions. So in your class, if you want to create an engagement and if you want to move your learners to an objective, you need to motivate them. And one way of motivating them to move towards an objective, towards a learning objective, is putting them in the right emotional frame of mind. When we experience happy emotion, we are more inclined to accomplish, to move. We feel more motivated. Just reflect for an instant. You would always love to go to a picnic, to a mall, to a place of enjoyment, rather than to a place of work. That is assuming that the place of work is harsh. Why? Because you feel more happy there. And what is happiness? Happiness again is an emotion. All right. So I was just trying to get to make you connect with your emotion. I was just trying to make an assessment of the kind of emotional state that you are in. Let me ask you another question. If there is one thing that you want your life to give you, what would that be? If there is one thing that you would want your life to give you, what would that be? Ah, happiness, health, stability. Okay, Sarita. Peace, health, honesty, satisfaction, peace of mind. Okay, Jaswinder. Peace of mind. Anybody else? Happiness. Healthy. Yes, Deepak. Mental peace. Okay. Are there more responses coming? Satisfaction. Remarkable achievement. Okay. And what is that remarkable achievement? If you look to the responses, dear friends, if you see in the chat box, relaxation. Thank you, Saraswati. If you see in the chat box, there are two things that I can, infer. I can smiling. Okay, Atanu. There are two things that I can infer from your responses. One is a majority of you spoke about mental peace. A majority of you. That means peace is something that is uppermost in your mind. Peace is something that majority of us think about. And those of us who have not responded, even they will agree that this is something that is uppermost in their mind. And what is that which is uppermost in our mind? What is that which we think so much about? Probably it is something that we don't get much of. Probably it is something that we are deprived of. Probably it is something that we are working and aspiring for and that we are not getting. Probably it is that we are getting. So I leave that to you. I leave that option to you to analyze, are you getting that or not? But one thing is there, peace is something that is uppermost in our mind. Happiness is the other word that I see in the chat box. If you look at it, if you go deeper, even with the peace of mind, what you are searching is actually happiness. Peace of mind is a condition. What will that peace of mind give? The peace of mind, the resultant of that peace of mind will be happiness. You'll feel happy. So if you look at it, subconsciously, all of us are aspiring, are moving towards this condition of happiness. Nobody mentioned money. Nobody mentioned a shiny new car. Nobody mentioned good relationship. Nobody mentioned career. Nobody mentioned I want to see my PhD, PhD getting completed, research papers getting published, promotions happening. Nobody mentioned that. And you represent the intellectual community. You represent a community which is intellectually advanced, intellectually solid. The thing that is uppermost in your mind is peace of mind and happiness, all that stuff. So what does that tell me? That subconsciously all of us, whether we are aware of it or we are not aware of it, are aspiring towards happiness. Something that gives us an experience like this. And that is why a session like this is relevant. It is pertinent. It is in the fitness of things. Do you agree with me or not?
Yes, sir.
Yeah. Thank you, Payal. Thank you. Thank you so very much. All right. Having said this, thank you, Ravindran. Thank you. Appreciate your responses, dear friends. It encourages me a lot. Which brings me to a fundamental question. What is actually happiness? How would you describe leap of faith? That is happiness, Payal. Could you please explain it? Could you please let us know more about it, Payal? How is leap of faith a happiness?
It is that unblinding trust, which I should say,
Mhm.
or trust in something.
Trust in something, that is happiness.
That is
Right?
the leap of faith, actually, which the slide had portrayed. After that, the what is happiness question came in.
Okay. Well, the slide, if you see the way I look at it, slide portrays someone, a youngster who is in the epitome of happiness. You know, lithe and gay and overjoyed. Something has happened, and she's leaping up in excitement. Perfect picture of what happiness moment would be all about, and so and hence that is the reason why I put it there. And I was trying to understand from you all, how do you see happiness? How do you see happiness? So, okay, leap of faith, I can take that. What else, dear friends? Anyone else who might want to? Quite many of us here. So, what would you say? What is happiness? How would you see happiness? If I was to ask you, describe or define happiness, fulfillment of expectations, that is happiness. Okay, Suresh. Contentment, yes, Jaswinder. Less regret about the past. Oh, wonderful, Chaitanya. That is wonderful. It is a fulfillment of desire. Okay, Sarita, thank you. Well, it seems like an odd question, but is it? Do we really know how to define happiness? Another important question is, yes, agreed. Do you think that happiness is the same thing to us as it is to others? Happiness for me may mean something else, happiness for you may mean something else, isn't it? Does it even make a difference in our lives? If there is no stress, okay, Saraswati, okay. So when we ask this question, these are the common responses that come. What is happiness? Be happy with the limited resources. Thank you, Deepak. Yes, limited resources, be happy, but if that be the case, then we would not work. So how this spells out, you know, people talk about it, people describe it in different ways. Some say it is a state, like some of you said. Some of you, for some it is a pleasure or contentment. Somebody said satisfaction. Somebody mentioned that. Can be internal, can be external. Yeah, it's an, isn't it? So, if you go by the dictionary description or dictionary meaning, it's Oxford English Dictionary says it's a simple definition. It's a state of being happy. A state of being happy differs from person to person. The definition of happiness. Yes, of course. Yes, of course. If you go a little deeper than the traditional definition of a state of being happy, you will say the state of feeling or showing pleasure or contentment. Practice and experiment. Okay. See, happiness is a state, not a trait. It isn't a long lasting permanent feature or a personality trait, but more of a fleeting, changeable state, isn't it? You're happy for something, and then when you move on, that feeling passes away. So maybe you get a promotion, you're happy at that instant when you receive the letter, you be in that state for an hour, for a day, for a two, but then that state goes away, isn't it? It can be equated with feeling or pleasure or contentment. That means that happiness is not to be confused with joy, ecstasy, bliss, or more intense feelings. Happiness is not to be confused with that. It is more diluted, I would say. Yes, like uh, like today in northern India, if you're there, you will see these days the weather is very foggy. Happiness is like a fog. You can see it from afar. dense and full of shape, but when you approach it, its particles loosen, and suddenly it becomes out of reach, even though it is all around you. You see what I'm talking about? When you see the fog from a distance, you can see it, but when you go through it, when you are driving through it, there is no fog. The particles, they disperse. It's just like that. We put so much of emphasis on the pursuit of happiness, but if you stop to think about it, the pursuit is to chase something without guarantee of ever catching it. Yes or no? So happiness is, if you see, it is not just one. What an explanation, especially fog. Okay, you want me to repeat the state? When you see fog, you see it from a distance. Imagine you are driving, all right? You are driving, and from a distance you see dense fog, and you have this feeling, oh my God, how am I gonna go through it? The visibility, I'm not able to see the road ahead. But when you go through it, you find that you are able to see the road. The particles are dispersing. Happiness is like that. You see it from a distance. It's like, let's say, for example, you are writing a thesis. I'm sure many of you would have submitted or are would be in the process, or you are writing a research paper maybe, and you have this conception. When it gets published, when it gets accepted for publication, it will make me overjoyed. It will make me very happy. So when you see it from a distance, you can assign a structure, a shape to it. But when you go through it, when you are done with your viva, when you are done with your submission, when the journal article gets accepted, you just go through it. That is what I mean when I equate happiness. This is a thought which I was trying to share with you. I was having this conversation with another gentleman, a couple, and they are working people, young people. The husband works in the marketing area of a very prestigious company. The wife has her own job, wonderful job, newly married. The wife is expecting. Okay, so it's like almost full term. He's into her. He's going to deliver a baby, right? Another 2 3 weeks time, and suddenly what happens? The husband catches this swine flu, H1N1 infection. It happened some time back before this corona thing happened. And imagine suddenly he catches that. Acha, what the condition nowadays, I'm sure all of you would be facing this. Uh, the trend is that people now usually stay alone. I mean, parents are there in their native places. They will travel to some bigger cities for work. And that is the condition of this couple. So they are all by themselves, no one else to fall back on. Husband catches H1N1 swine flu, and then unfortunately he contracts what is known as a GB syndrome. A GB syndrome, those of you who have experienced this, is known as Guillain-Barré syndrome. It is a viral attack in which the body, the immune system gets hyperactive, and there is loss of strength in muscles and all that stuff. It's a serious condition. And he is hospitalized. Imagine the condition. This fellow, he refuses to give in. He refuses to give in. So what he does is, he's very active. He has been very active, running around, a do or die attitude kind of guy. But he's down suddenly with this kind of thing, which has put him on a bed in a hospital. So what does he do? So he invites people. He talks to people. Asks them to give him books so that he can utilize his time. Goes through TED talks. Goes through different resources. Reads, trying to put himself. Trying not to be dominated by this event that has happened. He goes through TED Talks, he goes through Deepak Chopra books, he goes through Oprah Winfrey shows, he goes through Tom Robbins books, and one thing comes out that all those people who were able to tide out their trying circumstances had one thing in common. Did that because they were able to harness one aspect, and that aspect was aspect of gratitude. Gratitude. Being grateful for whatever life has offered us. This is not some philosophical statement. This is not some motivational stuff statement. This is something that has been researched. If you look at it, why happiness eludes us, why happiness escapes us, why we keep, searching after happiness and yet not seem to get it. You probe deeper. The reason is that first of all, we don't know what will make us happy. Secondly, we think as though happiness is some end point that we are going to achieve, and we lose the journey that is actually the precursor, that is actually where the happiness comes from. Think about it. You go to a beautiful place in your vacation. You think, when I reach there, I'll see this, I'll visit this restaurant, I'll visit this place, I'll do so many activities, and I'll be happy. And by focusing on that, you lose sight of the journey that you travel. You see. Also, we focus on things that we do not have. We focus on things that we don't, that are lacking or we are trying for, and by doing so, we develop a sense of dissatisfaction. We are not grateful. We think of all that is not there with us, and it makes us feel miserable. So if I'm somebody working in a private institution, I aspire for a government job, and because I don't have a government job, I think that I'm miserable. I look at people in NITs and IITs and I see how intelligent they are. Oh, they are doing wonderful job. मजा हो रहा है उनका, enjoying their life like anything. And the IITians and the NIT faculty, they look at us and they see, oh God, what is this mess I have got into? So much of pressure, so much of workload. People think I'm having a wonderful life. I know what kind of miserable shit I am in. Always dissatisfied, discontented, disagreeable with ourselves. Where is the room for gratitude? Where is the room for gratitude? Tell me if I'm wrong somewhere. Greek mythology speaks of a character known as Tantalus. Tantalus. And what is the story? The story is that Tantalus is supposed to be the son of Zeus, who somehow got angry with his own son and banished him to the underworld. The underworld, according to Greek mythology, is another name for hell. It exists beneath the ground, and it is hell. So what does Tantalus do? How is he depicted? So he's depicted in a stream, in a river, where there is water till his waist, and there is a tree laden with fruit. No, not Lucifer, Tantalus. Lucifer is Satan in Bible. I'm not talking about Bible. I'm talking about Greek mythology. So Tantalus is depicted in a wading in a stream with waist high water, and there is a tree laden with fruit above him. So whenever he feels hungry, he has to just reach out, pick up a fruit, and eat it. And whenever he feels thirsty, he has to bend down and drink from the stream. But his curse is that whenever he reaches out to the fruit to pluck it, the fruit, the tree recedes back, moves back from his reach. So he's not able to grasp it. And whenever he bends down to drink water, the water recedes, so he's unable to drink. And that is Tantalus's curse. He feels hunger, he reaches out to pick a fruit, the fruit moves away. He feels thirsty, he bends down to take water, to drink water, the water level recedes, goes down. He's unable to pick water and drink it. And it's a beautiful metaphor, it's a beautiful allegory the Greeks have developed to capture the essence, to capture the sense, to capture our lives, all of us, the current lives. We aspire for so many things, and then when we get them, we don't know what to do. The so-called happiness seems to elude, seems to escape, seems to be constantly beyond our grasp. Do I make some sense here? Do I make some sense here?
Yes, sir.
You've been told once you complete your class 10, you score good marks, things would be happy. Life would be set. This is what you were told. When you crossed your class 10, you were told the same thing for your class 12, you were told the same thing for your graduation, you were told the same thing for your post graduation, you were told the same thing for your PhD, you were told the same thing that you would get a government job, you'll teach in a prestigious institution, then you'll be happy. You were told the same thing, and yet now here you are, all of you, doing the best that you could have done, reaching everything that is supposed to be coveted. All of you. Ask yourself, are you really happy? Don't tell me. Don't tell me. Don't tell anyone. Ask yourself. Can you relate to this picture that you see in the screen before you? Do you see your image in the image of this person that you see depicted in the screen before you? Are you like that? How much of congruence you feel? Now, my intention is not to put any negativity. Please don't misunderstand me. I'm here to talk about happiness, dear friend. And I'm just trying to make a point. How much of sense do you see in what I'm talking about? How much of sense do you see? How much of sense do you see in what I'm talking? Sarda, is it audible now? Am I audible now?
Relating with your words by every bit, sir.
Thank you, Dr. Panganal. See, as our lives come to include more empathy, more gratitude, more meaning, we stop feeling sad. Thing is that we don't practice it. One of the misconceptions that about happiness is that happiness is being cheerful, joyous, and content all the time. Always having a smile on your face, that is happiness. No, it is not. Being happy and leading rich lives is about taking the good with the bad and learning how to reframe the bad. Reframe the bad. In the Journal of Experimental Psychology, there's a Harvard researcher known as Jordi Coidback. He talks about emo diversity and emotional ecosystem, and he has found that experiencing a wide range of emotions, both positive and negative, is linked to positive mental and physical well-being. Not only do we tend to misunderstand what happiness is, we also tend to chase it in the wrong way, as a matter of fact. The researcher from Harvard, Sean Acor, who wrote the HBR article on positive intelligence, he mentions that most people think about happiness in the in a wrong way, if I can use that word. The biggest misconception of the happiness industry is that happiness is an end and not a means. Imagine that. Happiness is an end. When we achieve this, when we get there, when we do that, then we'll get happy. So we think of happiness as an end, not as a means. We think that if we get what we want, we'll be happy. But it turns out that our brains actually work in the opposite direction. We sometimes tend to see being happy as the end goal. But we forget that what is really important is the journey. Finding out what makes us happiest and regularly engaging in those activities will help us lead a more fulfilling life. In other words, if we are not happy when we are chasing happiness, we're happiest when we are not thinking about it. When we are enjoying the present moment because we are lost in a meaningful project working towards a higher goal, imagine the condition that you are in. That is what being happy means. Do I make some sense? Now, I have a question from you. Why being happy matters? Why is it important for us to be happy? I'll stop sharing so that I can interact with you and see. Can I have your videos just on, please? If you can. Why being happy matters? Why do we have to be happy? Expectations from whom, Ravindran? Great. Lovely to see you. Thank you. Thank you. Thank you so much. That's okay, Saurav. That's okay. Camera is not working. It's beyond your control. That's okay. Why being happy matters? Please don't worry about your backgrounds. Please don't worry if you are sitting in your bed in a rajai. That's okay. Please don't worry if you are having food also. That's okay. That's okay with me. Please don't worry if you have not had a bath or if your hair is messy. That's okay with me. That's perfectly fine with me. Why happiness matters? Deepak says end of any activity. That's something we'll all seek every moment. Go deeper. Go deeper. Why being happy matters? मतलब आप मुझसे पूछ सकते हैं ना कि भाई मैं खुश रहकर भी क्या करूंगा? What will I do if I'm happy? Have you ever thought about this? Thank you, Abhishek. Very kind of you. Very kind of you.
Sir, I have an input. May I?
Yes, please. Please feel free.
Yes, sir. A famous sage ascetic Bodhidharma once said that happiness is not the effect of anything; it is the very cause of everything. The moment we stop associating our happiness to mortal belongings and our fetishes, the more happier, the happier, the more happy we become in our lives.
That's amazing, Dr. Swami. That's really really amazing. Thank you. Thank you so much for sharing that. And I understand the region where you are from. There is a lot of influence of Bodhisattva, and when you talk about happiness, of course, the Buddhists philosophy is replete with insights on how to develop eternal happiness, and they talk about compassion and so many other things, of course. But I'm asking from a layman term, from a layman like me, from an ordinary mortal like me, why do I need to be happy? Or if I'm working in a division, in a department like you all, why? How does being happy relate to my teaching? I'll complete the same syllabus, isn't it? I'll take the same number of classes, isn't it? I'll be the teacher that I am. Whether I'm happy or I am sad, why should I need to be happy? That is the question I'm asking.
Sir, one cannot be, satisfied with their, give their 100% in their work until and unless he is happy with his own work. I
Okay.
believe that, sir.
Yes, Abhigyan, of course. I do agree with you. One cannot work at his best efficiency if there is no happiness in work. Thank you for saying that. Agreed. Divya says happiness matters for being healthy. Yes, Divya. Happiness matters for
Sir,
being. Yes, please.
sir, being happy makes my emotional feeling direct in a positive direction.
Okay. Yes, indeed. Yes, indeed. Thank you. Thank you so much. Uh, yes, is there somebody else? Happiness leads to help others. Okay, Jiva. Self-actualization, Maslow's pyramid. Oh, wonderful, Payal. Wonderful. That is absolute happiness. Yes, indeed. When I'm happy, I'm with ease with me self. Whatever I do will be perfect and I work at highest efficiency. Yes, Rajesh. Absolutely. I'm so glad you brought that out. So, British Telecom did a research. And what they did was, and British Telecom, of course, you are aware, it's a leading telecom company. So they did a research on their employees. So what they did was they offered their employees free snacks and free beverages. Okay, beverages as in Coke and Pepsi and all. And then uh, they asked them to record their moods, their emotional condition, state of mind, emotional barometer, of course. And then they calculated the number of calls these people made. ठीक है जैसे आप लोग एयरटेल या वोडाफोन या जियो यूज करते हैं तो कस्टमर केयर कॉल आता है ना just like that. And they found that people, when they were happy, they made more calls in the same duration vis-a-vis those people who were not in that emotional mood of mind. So much so that the efficiency went by 13 to 15%. And it is documented that happy employees are more productive. Happy people are better workers. Those who are engaged with their jobs and colleagues work harder and smarter. Imagine what I'm talking about. A happy person is more engaged with his work or her work. A happy person is more engaged with the colleagues. So, अब अगर देखिए, if you look at it, if I am working in your department and if I'm happy, I will transmit that happiness to the people all around. I'll foster positive relations. I'll make good connections with all. I'll be more efficient. I'll create an atmosphere of positivity the department impacts. It flows. God forbid, if I am the HOD, I will transmit that positivity. I'll ensure that everybody remains happy so that the entire department progresses. Look at it from the other point of view. If I'm not happy with myself, and I'm not talking about one solitary instance, one instance, I'm not talking about that. I'm not talking about the day I have a fight with my wife. I'm not talking about the day when somebody bangs my car. I'm talking about a constant thing. If I'm not happy, what will happen? I'll carry that irritation, I'll carry that negativity, I'll impact people around me, I'll turn the department into a hell. And many of you can relate to what I'm saying. many of you, we work with toxic bosses. We work with toxic people in positions of power who control our lives. They are unhappy inside and they create a poisonous atmosphere around all of us, make our lives hell. That is the reality you are witnessing all. Go back, reflect. Unhappy people exist in the workplace, they exist in the home front. At workplace, they make the workplace hell. If you are unfortunate enough to be tagged with an unhappy person in your household, he'll make your life miserable. There are so many reasons which make people unhappy. All of you. All of you. And if you look at it from that perspective, you will find how and why being happy matters. It matters a lot. It's not about pleasing others or pleasing somebody else. It's about creating those vibes, those positive vibes. Happiness and productivity, it matters. It's linked. And that is why the world over there is so much of emphasis, so much of research going on why happiness is important. What is the reason why it is important? Fortunately, we exist in an industry in which productivity is not that much measurable. I mean, education line, whether you teach excellently well or you teach moderately well, how are we going to differentiate? How do you differentiate yourself with another teacher? With some organizations, they have some institutions, some universities, some institutes have a feedback system, but the feedback system is manipulation. You can't just depend on that. Unfortunately, we don't have an educational institutions. We still don't have a system in place which measures this the kind of performance. Feedback pile is not a very how shall I put it, a very authentic way of measuring teaching effectiveness. You are judged by people who have no capacity to measure your intellectual level. Degree of satisfaction, Sarita, is individual. It cannot be integrated into a performance system appraisal thing. I mean, if let's say, for example, there are two teachers, for example, Payal and Sarita in my department, how do I differentiate who is a better teacher? The existing subsystems don't give you a clear-cut system on which the differentiation can be made. Student feedback is faulty. Academic feedback, this AQI index that we are talking about, API that we are talking about, again, it gives you that you are a good researcher, but can you be a good teacher? You know better than I do. We have researchers, but they fail as teachers. We have teachers who have got difficulty in writing research papers. It's the bane of educational institutes. I don't know how far you agree with me. There is no system that can tell me which one is better, which is not. So I will not go in that detail. I'm talking about main. I'm talking about just this aspect about happiness being a factor. And that is why, you see, when people are unhappy, what happens? There is no engagement. Engagement means you don't relate with your work. You may be working in educational institutes, you may be drawing a handsome salary. Okay, I take it. But do you really, do you really feel connected to your work? How many of you feel connected to your work? How many of you feel engaged with your work? How many of you feel the excitement when you get up in the morning that, okay, today I'm going to rock my class like anything. Today I've got this new topic to teach. How many of you feel that every single day when you come back to your institution, report to your institution, or log in today's time? That is,
So
Rakesh, if you can hear me, could you please mute yourself? So how much what I'm saying is making sense to you, dear friends? Let me have a show of hands.
Absolutely right, sir. Absolutely.
Thank you. Thank you so very much. Again, I'm so grateful to you. Disengaged, unhappy people aren't fun to work with and don't add much value. They impact our organizations in profoundly negative ways. It's even worse when leaders are disengaged because they infect others with their attitude. Oh, Rakesh, that's okay. That's okay. Their emotions and mindsets impact others' moods and performance tremendously. How we feel is linked to how we think. So, thought influences emotion, and emotion influences thinking. And it's time to blow up the myth that feelings don't matter at the work. Feelings do matter. What kind of emotions the leader is generating, it does matter. There is clear neurological links between feelings, thoughts, and action. When we are in the grip of strong negative emotion, it's like having blinders on. You understand what are blinders? You know, if you've seen the horses in the carts, you know, you see they have covered their eyes. These are the blinders, so they're not able to see. We focus only on the source of pain when we are under the influence of a negative emotion. We don't process information, we don't think creatively or make good decisions. So, frustration, anger, and stress can create an important part of us to shut down, and that part is thinking and being engaged. Imagine that. Imagine that. You see, in one of the institutions, in one of the organizations, there was this departmental head who would stand outside the classes every time and watch what time the classes started. And if somebody was late by a minute in either entering the class or exiting the class, he would take disciplinary action. And he would say that academic discipline is like this: the classes should start on time and end on time. And he would take pride in saying that. Imagine the toxic environment this person had created. Frustration, anger, and stress in the faculty members led to an actually decline in the quality of teaching. The time constrains me. Otherwise, I could have shown you the connection. I'm sure you can relate. You can always relate. Yeah. All right. Let me. When employees are happy, they feel invested in organization's goals and are more compelled to work. Happiness increases productivity because it leads to higher engagement. So, happy employees are also more present. All these factors come together to bring organizations increase productivity and profitability. Of course, the research is on corporations, but if you see it in the context of academic institutions, you will see the same thing. When I'm sure you would be working with different kind of departmental heads or vice chancellors or directors, those who give you the freedom which makes you happy, you feel more productive at work because your creativity, and there is a neurological link. When you are happy, your centers which control your creative thoughts, they are activated. You are more creative. You're more creative. You bring out novel ideas, novel implementation thing, and these are so very essential even for academicians. You know, researchers say that happiness made people around 12% more productive. That is a research that was conducted and it gave the finding. There is this Professor Oswald of University of Warwick who, if you search on the Google, you'll find his papers on this. Companies like Google have invested more in employee support and employee satisfaction. They have seen a growth in their profitability as a result. Can you imagine? For a company like Google, the productivity after investing in ensuring that employees are happy, for Google, the productivity increased by 37%. Imagine that. The driving force seems that happier workers use the time they have more effectively. You understand what I'm talking about? It's not that the happy workers work more, no. But in the same time frame, they are able to achieve more, which means that their efficiency increases. And that is how their productivity increases. Now, how does it help us? How does it help us as teachers, as university professors? How does this fact or this statement help us? Any idea? See, for the simple thing that yep, for the simple thing that if you have to be productive now, what are the areas that you will be productive? Suppose you are a teacher and you have a class to teach. If you want to be productive, how would being productive mean? So being productive would mean that your class becomes more engaging. Your students relate to what you are teaching. They imbibe what you are disseminating them. How will you make that happen? You will make that by creating an environment of happiness and positivity. Now, creating an environment of happiness and positivity, does that mean that you are going to, tell them jokes or make them laugh? No, that is not the idea. That is not the idea. By focusing on happiness, you create an environment a conducive environment in which students would want to learn more. They feel connected, they feel engaged. That is what I'm talking about. Of course, you cannot solve a student's life's problems. That is something for him to bear. But you can create a vibe where students feel happy. And if you notice, there are people like that which create this kind of environment in their classes. And students love to be in those classes. For you, it will add as a booster to your own self because seeing happy people around you will make you happy. And if you are happy, you will create those happiness vibes all around, even in the department, even in amongst your colleagues, even amongst your superiors. That is how it impacts you. Does it make sense? Does it make sense? Anybody would like to, mention or share any thoughts? Are you there at the other end? Let me share with you a statement, a quote by Steve Jobs. Thank you, Saurav. Your work is going to fill a large part of your life. And the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking. Don't settle. As with all the matters of the heart, you'll know when you find it. This is Steve Jobs for you. What is he talking about? What is he talking about? What do you think is he talking about? You said this is going to be an interactive session, dear friends. Now let me know. What do you think? What is he talking about? Not settling until you find true happiness. No. More when if you go deeper, go further than this. See, the statement that needs to be that needs to, we can create an innovative. Okay, the only way to be truly satisfied is to do what you believe is great work. The focus is here. How do I believe that what I'm doing is a great work? How do I believe that? When the work that I do relates to my values. I really want to do that. Ask yourself this question, dear friends. How many of you are doing something that you really love doing? How many of you are teaching because you love teaching? How many of you are writing a research paper because you love doing research? How many of you are attending this session or this FDP because you have this inherent thirst for knowledge? How many of you really wanted to be, where you actually are right now? Don't answer me, just think. We make choices based on others' expectations and validation, removing ourselves from the equation. And that is why happiness eludes us. So I'll give you a formula for happiness. Would you want me to share that? This is what it looks like. Karma, where P stands for positive emotions, E stands for engagement, R stands for relationship, M stands for meaningfulness, and A stands for accomplishment. I'm facing some power issues at my place, dear friends, as you can see. So I'll try to continue and make it quick. This is the happiness formula as created by Martin Seligman. And he says that somebody who adheres to these 5 factors, gets or generates that kind of generates this kind of happiness, right? So P stands for positive emotion, E for engagement, relationship, meaningfulness, and accomplishment. So what is meant by positive emotion? Positive feeling would be, optimistic people are able to conjure up positive feelings faster than pessimistic people. Having positive emotion enables you to bounce back from setbacks. So they can understand that a single failure or small obstacle does not have to drag them down. They believe that they are in control of their life. Friends, give me a minute. I'll just I'll log in from. Can you hear me, dear friends?
Yes, sir.
Yes.
Sir.
Just wait, participants. Dr. Rashid Jair is logging from another system. Okay, participants, please stay with us. Due to power cutoff from expert site, he's trying to log in from different system. Just wait 2 minutes. Just wait.
Can you hear me?
Yes, sir. Yes, sir. You are audible, sir.
Yes, sir.
Okay, thank you so very much. I'm so sorry for this inconvenience that has come up. Please, thank you for bearing with me.
Okay, sir. No problem. No problem.
Okay, thanks a lot. Just give me one more second. Let me make some arrangements so that it will not take long. I'll just take hardly few seconds more. That way, I'm trying to make you see my face as well. Okay, can you see me?
Yes, sir. Yes, sir. Yes, sir.
Thank you. Thank you
No,
for
no
bearing with
issue,
me.
sir. No issue, sir. This is the practical scenario for to organize any program in online mode, sir. It is practical.
It also, is a test for the emotional intelligence that I
Yes,
have,
sir.
the
Yes, sir.
being happy. That is what we've been talking about.
Sir.
All right.
Okay,
So
thank you.
I was talking about this this PERMA model, wherein we spoke about five aspects: uh, positive emotions, and then engagement, then relationships, then meaningfulness, and fifth is accomplishment. So this model was given by under a great deal of research by Martin Seligman. This is known as the happiness formula, and he studied what makes people happy, what makes people flourish, what makes people be happy in whatever they do, and how can we be happy? So first thing that he spoke about, first factor that he spoke about was that if we one factor which is the source of happiness would be positive emotion. So what is meant by positive emotion? What is meant by positive? Does it mean feeling happy all the time? Does it mean feeling optimistic all the time? Does it mean that? What would you say? Anyone? Any ideas? Positive emotions mean being able to bounce back from adversity. You see, being able to overcome the impact of negativity. All of us have faced innumerable challenges, especially in the past few years, 2 years. The upheavals that we have on the personal front, on the professional front, has been immense. Has been immense. No one has been bereft. No one has been, spared that at sight of time, as we say it. But how many of us have been able to, bounce back? Have been able to, like the example which I shared with you earlier. This fellow who was having a job, whose wife was expecting their first child, came down with H1N1 and later on the GB syndrome. This was a challenging situation. This was a negative situation. And yet he tided over. This is what is meant by having positive feeling, having positive emotion, being optimistic, being able to see the silver lining behind every cloud. That is what is meant by positive emotion. Second is engagement. Do we feel connected in what we do? Many times we choose something which runs contrary to our value. We may internally believe something else and we do something else. We are doing something which doesn't relate to us anymore. So there is always a disconnect. There's always a disengagement between what we think, what we are, and what we do. And that is a constant source of tension, of torture for us. Ask yourself, the people that we are associated with, the friend circle that we keep, the neighborhood that we keep, do not relate to us. The colleagues that we are do not relate to us. The organization that we are in do not relate to us, do not connect with us. And yet we are made to exist in those situations for some or the other compulsion. There is no engagement. And because there is no engagement, there is a constant source of stress, of anxiety, which is, which we are subjected. And we keep beating our heads in agony, misery. What is this mess I've got into? अरे यार कहाँ फंस गए? We are disengaged. And because we are disengaged, there is no happiness. There is no joy. We are doing it. We are living the life of a machine. We are doing it because we are doing it, but we are not enjoying it. It doesn't give us happiness. Third factor is relationship. Human beings are hardwired to exist in a community. To exist in a community. To exist in a social circle of their own. We are hardwired. We cannot exist in isolation. So when we are programmed, when we are, when I say hardwired, I mean the neural connections in the brain are like that. They make us exist. They make us want to exist in a social circle, in a group. That group can be, okay, you want me to increase the volume? Is it better now? Is it better now? Is it better now? Can you hear me now better? If you can, please unmute yourself and let me know if you can hear me now.
Yes, sir. Yes, sir.
Okay, thank you. So kind, so kind. Give me a minute. Let me have. Okay. So human beings are hardwired to exist in a community, in a clan. Now, when we are hardwired to exist in a clan, in a community, what happens? Somebody mentioned Maslow and hierarchy of need and self-actualization. I think it was Payal who mentioned that. So Abraham Maslow, he gave this hierarchy of needs uh, to explain what motivates us, what impacts our actions. And in that hierarchy of need, in that pyramid of needs, you will find that the sense of belongingness is is placed higher, which means that we are driven by a sense of belongingness. We want to belong to a community. We want to be a part of a community. That is a inherent desire, that is an inherent trait within us that impacts our actions. So you have been told in the earliest childhood that study well. If you study well, you'll get good marks. And when you get good marks, what will happen? Sure, people will look up to you for inspiration. People will look up to you with appreciation. People will look up to you with praise. This is what we've been told. This is what has been the driving force. So we have been doing things to make ourselves more acceptable, more agreeable, having a place of us for ourselves in the social circle that we have. Think for a moment. This is how we have been driven. So having good relationships in the social circle that we are a part of is a source of happiness for us. Imagine, just you reflect, you go back, you're having a strained rapport with anyone in the office, in the personal front, with a Taya, with a chacha, with a cousin, with a brother, with a sister, with a wife, anyone. Imagine the meditation. And imagine if it happens, it keeps happening day after day, regularly. What happens? Meaningful relations, source of happiness. M is meaningful, finding something of substance in what you do. So maybe if you are teachers, do you see something of value, something of substance in what you're doing? Are you doing it because you love doing it? Or are you doing it because you have to do something, and because this is something that seemed to be easy to do, you are there, or you just found this profession all along the way? Many of us maybe would have made better artists, would have made better painters, would have made better musicians, maybe sports persons. But we were told, what will you do with all this? It doesn't offer you, uh, won't offer you prestige, it won't offer you money, it won't offer you a good life. So you are caught. do I derive meaning? And that is a question which impacts, which is there in front of all of us. A is accomplishment. Last. What is that which is worth achieving? Are we achieving? Are we able to achieve our objective? Are we able to achieve our goals that we have set for ourselves? So if you look at these 5 factors, practicing these 5 factors makes us, witness or experience happiness. Now, if you look at it, what is that factor which enables us, to be able to witness, to be able to experience all of this? That is where the role of emotional intelligence. How do we realize? How do we make this model, PERMA model, or this framework implementable? And for that, we need emotional intelligence. So what is emotional intelligence? How many of you are familiar with this term? All right. So I can see in the chat box people talking about attendance link. Okay. Friends, how many of you are familiar with this term, emotional intelligence? Let me know what it is that you understand from it. I've been speaking for quite some time, so I'll take a pause. I'd like to listen to you. I'd like to confirm whether you are there on the other side or not. Let me know. What do you think this term is all about? I'm not able to hear you. Could you please be ready? Hello.
Hello, this is Mognon in here. So emotional intelligence, as you said, like it's, I believe there's the capacity of being aware about our own emotions and to act empathetically towards the surrounding.
All right. Thank you so much. You see, there are 2 things, emotions and intelligence, in this world, in this term of emotional intelligence. And for long, it has been assumed that intelligence is all about logic. So the more logical you are, the more thinking oriented you are, the more intelligent you are. Quite logically. So even in our scenario, the academic scenario that we talk about, it's something that is very, very pertinent. I need to download information. I need to give knowledge. I need to share facts. So the more facts I can keep in my brain and the more facts I can share, that is what will make me a good teacher, an effective teacher, a knowledgeable teacher, isn't it? The same idea was led in organizing. In the past 2 or 3 decades, when productivity has been researched, it came out that IQ is not the only factor impacting the effectiveness of leaders. There is another factor that came to be known as EQ, later on as
एवोल्यूशन है देखो खाली 10 पे दिखता है एवोल्यूशन कितना है देखिए
Abdul, could you please mute yourself? Abdul Lakib. As the research is evolved, as the studies evolved, and as the work of Howard Gardner in the theory of in the field of multiple intelligence came out, it came to be known. It emerged that emotions play a very important role in creative thinking, in decision making, in practically everything, in all our actions, in all our thoughts, in all our feelings. Because human beings are not uh, people of reason, they are people of emotions. And when this came, this thing came into being, a whole new body of research started happening. So, emotional skills, emotional intelligence is a cluster of traits with emotions at their bench. So, it has about 5 components: self awareness, self management, self regulation, empathy, and relationship building. What is meant by self awareness? Self awareness means being able to see, being able to witness the emotion that we are in, being aware of the emotion that we are in. Hello, can you hear me?
Yes, sir.
Can you hear me?
Yes, sir. Yes, sir.
Sorry, seems to be some switchover. Seems the power is back. Okay. So self-awareness means being aware of the emotion that we are feeling at the moment. You remember we started this session by uh, making you pause and have a connect with the feeling that you are in. Most of us are not aware when they are witnessing an emotion. Being in tune with the emotion that we are in enables us. Give me a minute, please. Friends, give me a minute. I'll. The power is back. All right. Can you hear me?
Yes, sir.
Why? Good. Now, thankfully, the power is back, so I can log in. Let me just share. This is what I was talking about. Yep. So this is the model of EI that we are discussing. So self-awareness is about getting in touch with the feeling, that emotion that we are in. Self-motivation is ability to motivate ourselves in adverse circumstances. And if you see, self-motivation here in this model of EI relates to positive emotion of the PERMA. When we spoke about positive emotions in PERMA, when we spoke about being able to bounce back from negative influences. So that is the same thing of self-motivation that we are talking about here in emotional intelligence. Self-regulation here means that sometimes the impulse comes to act, and between that impulse and an action is a small moment wherein you have to make a choice. Self-regulation means being able to control the impulses to act. Empathy would be about feeling someone else's pain. Empathy is a very important factor in creating engagement and relationships of the PERMA model. And finally, of course, the social skills. Social skills is nothing else except about uh, relationship management. So if you see, emotional intelligence relates to PERMA model of happiness, and that is how happiness is linked to EI. Being emotionally intelligent means, I'll ask you, I'll share with you. I'm just rushing because there seems to be a little constraint of time. What you see before you, what do you see before you? Let me ask you this. To navigate through a city like this, what you will need is a GPS, a global positioning system. Think of EI as your GPS. And there is a comparison if you look at the table before you. If GPS helps you identify your current position, your EI helps you in identifying what you are feeling right now. GPS prompts you to identify where you want to go. EI will prompt you to decide on an outcome, what you would want to achieve from the situation. GPS assists you with dealing with obstacles and changes in the environment as they occur. And EI will help you in creating the outcome that you desire. GPS recalculates new routes to your destination. EI tells you how to get back on course that will bring you satisfaction and success. GPS helps you reach your intended destination. EI will make you learn gracefully how to cope up with an ever changing environment. So, in short, if you look at it, the role played by GPS in our devices while we are navigating a complex city like what you see in the screen, EI helps us navigate this rigmarole of life. And hence, GPS can be equated to emotional intelligence. So, that is all from my side, dear friends. Thank you so very much. I hope you enjoyed as much as I did. If there are any questions, I'll take them now. If you want to reach out to me, my contact details are there on the screen. You can have them. If you want this presentation, I'll share that with you all. And thank you. And there is a request. There is one request that I will make from all of to all of you, dear friends. Is the chat box? Okay. I'm sharing a link in the chat. Could you see it? This is some. Thank you, Saurav. Thank you so very much. Please have a look at the link that I'm sharing in the chat here. I'll request you to please fill up this questionnaire. It is for my research that my company is doing. I'll be very grateful for your inputs. If you like the session, let me know how. And if there are any questions, I would love to take them right now. Any comments, any views, any questions, any thoughts that you would like to share? Now would be a good time. And I'll request each one of you to please click on the link that I have shared in the chat box. Please fill up the questionnaire. Thank you so much. Thank you, Gurvinder. Thank you, Deepak. Thank you, Rakesh. And if you can switch on your videos, I can take a screenshot. This would be closest to a group photograph. It will. I'll be really glad to. Great. Wonderful.
Thank you, sir, for your wonderful session, sir. We are.
Thank you. Thank you, Dr. Kontran. I hope you enjoyed as much as I did, dear friends. Thank you so very much. Wonderful to be here with all of you. Please feel free to share your thoughts. Please feel free to share your questions. I'll also request you to please fill out the questionnaire, the link for which I've already posted in the chat box. I will need it for my research that my company is doing. I'll be really grateful for your cooperation.
If you're happy with me, please do fill it up. Sharing my contact details in case you might want to get in touch with me. This number is available on WhatsApp as well.
Sir, really, we are very grateful to you for sharing your thought regarding emotional intelligence and happiness. So it is right now in this situation, sir, it is very much uh, helpful to our daily life. So we are actually going on in different stress, maybe in workplace, maybe in house related different sources they are coming. So in this situation, this type of motivational talk, it is very much important, and it is helpful to our uh, each and every participants. So thank you, sir, for delivering your wonderful session.
Thank you. Thank you. I'm so happy. And this is what we do. And emotional intelligence, dear friends, is something that is very, very close to my heart. And I would love to work and help out as many people as we can. This is something that my company does. As I was mentioning, the initiative that we have, Project Siddhamana, we keep holding workshops on EI, on positive psychology, reaching people out. And I'll tell you, ironically, dear friends, the teaching community is a community which has the maximum stress, which works under tremendous pressure. And this is one community about which nobody is aware. You talk about the stress levels of the defense forces, you talk about the stress levels of police forces, of medical professionals, of doctors, of health workers. Nobody talks about teachers. And everybody thinks, irony is, everybody thinks teaching is an easy job. And these are those people who have no idea what teaching entails. If you see, when the pandemic came and when we shifted from online education, suddenly, so many of us had to make so much of choices, so much of adjustments. And even now, the work has gone 3 times, 4 times in the teaching fraternity. Tell me if I'm wrong. Teaching is just a very small part of what we do. Teaching administration is something that all of us are doing day in and day out, and it is so very stressful. And nobody talks about that stress. So I'm very thankful to forums like NIT Manipur for events like this, and I'm very thankful to people like Dr. Kalyan who gave me an opportunity to reach out to this aspect of the fraternity, dear friends.
No, sir,
And I'll be
it's our pleasure, sir. You are here.
thank you. And I look forward to associating with you, to talking, to have more such discussions with you, and help with whatever we can. And I think all of us should come together and hold hands together so that we can carry this and be strengths for each other. So any thoughts from your side, dear friends? Any questions that you would want to share? Any questions you have to ask? Any observations? Any experiences that you might want to share in relation to what we discussed, what we said? I would welcome you. How to deal with toxic bosses? Of course, it's terrible. It's terrible. I mean, a toxic boss or a toxic mother-in-law. My goodness. So, Payal, where are you, Payal? I don't see you. So, will it be? Would you be comfortable if you? Okay, got it. So, Payal, first thing is managing boss is an art, and we need to find out what drives their behavior.
The actions that we do, the behavior that we express is always because of an internal need that we have. Usually people who create toxicity or people who create this unhappy environment are unhappy within themselves from themselves. They crave for affection, they crave for acceptance, or they are the spoiled brat who have never been given the tight end of the stick, as they say. So you deal with toxic bosses by creating boundaries. You need to you need to understand them. And giving a direct answer might not be relevant because it's too short a time. We teach our entire course on handling toxic bosses. As a matter of fact, I would have loved to do that in an FDP session, but then AICTE will not accept this because they talk about stress management. They will not take this topic. It's a relevant topic. You understand what drives their behavior. You understand what motivates them to why are they doing this. And once you start understanding them from this angle, you become better equipped to handle them. That is number one. Number two, what happens is the moment we are with a toxic boss or with a toxic individual, the moment when he says something or does something to us, we come into that reactionary mode. That is where the self-management, self-regulation aspect of EI comes into being. Instead of totally blasting away, instead of being swayed by your emotion, exercise control. Tell yourself that unless and until you want, nothing and no one would be able to disturb you. And you will see the toxicity going down. You will see yourself being more equipped to handle that. That is the best I could have done in the time slot that is there, Payal. I hope I have been able to answer your query. If you want, I'll be happy to discuss more with you at a later stage, maybe. I hope that gives you an answer, Payal. Thank you.
Thank you, sir.
Good question there. Someone says career है जो पैसा देता है, passion है जो खुशी देता है, काश दोनों एक हो जाएं. Please share your views, sir. Okay, Ruskin, दोनों हमेशा एक ही होते हैं. दोनों हमेशा एक ही होते हैं. Passion and career really are not different. If you see जिनकी biographies, you want me to respond in Hindi? You want me to respond in English, Ruskin?
Sir, in English, you can.
Okay, great, Ruskin. Where are you? Where can I see you, Ruskin? I want to see you. Where you are? Can you just switch on your video, Ruskin?
Yes, sir.
Thank you, Ruskin. Good to see you. Which area you are from, Ruskin?
Sir, from Northeast Imphal.
Okay, great. So I don't know who these people are who say careers give you money and passion gives you happiness. I don't know who these people are. But one thing is there, they have no idea of what a career is. They have no idea of what passion is. When you see, what is passion? Passion is something you feel very strongly about, right? So somebody is passionate about dancing, maybe. Somebody is passionate about gardening. Somebody is passionate about designing. When you pursue your passion, the passion comes from deep within you. It comes from your values. It comes from deep inside you. You love doing that. When you are engaging in your passion, you lose track of time. And these days, things are available. The infrastructure is available to make your passion your career. All those people whose biographies we read are the people who made their passion their career. Imagine they did something which they loved doing and they made money out of it and they created a life out of it. So many examples. Who are career and passion different then? They are one and the same. It is these people who instill in us a sense of duality, and we think that they are in a state where they can judge about us better. So we follow their rules and we end up being confused. कि यार career बना जमा करने में, to develop a career the entire life bent. I didn't pay attention to my passion. Now I have a so-called career, but I don't relate to it.
My passion was something else. This is the tragedy of majority of us face. Am I
Thank you, sir.
able to convey an answer, Ruskin?
Yes, sir. Yes, sir.
Thank you. Thank you
Yes,
for
sir.
asking
Yes.
that. Thank you for asking that. Lovely question. How one can overcome fear of death? Hey, Gurvinder, something coming from you? Well, do you know fear of public speech is rated even higher than fear of death? It is an eventuality. It is an eventuality. When you are afraid of death, Gurvinder, what is happening? You are thinking about death. You are thinking about death even while you are living. Look at that. You getting what I'm trying to tell you? You are thinking of death when you are still not dead. You are living, and yet you are thinking about death. So what is happening? Your mind is playing the tricks on you. And when it creates those pictures, and I can understand where this question is coming from. Maybe you have witnessed death. Maybe you have seen death, maybe in your surroundings, in your family, and you are scared. So what is happening? Your brain, your mind is creating pictures of death and misery, which is not the reality. The mind has a tendency to keep us either in the future or in the past, never in the present. Because if you are there in the present, you don't think. And when you don't think, the mind is without any work. So the mind controls you by putting you either in the future or in the back. The past is something you cannot do anything about. The future is something you don't know. So instead of staying either in the past or in the future, stay in the present. That is the power of now. And that is how you overcome fears, including fear of death. I hope I'm able to answer that, Gurvinder. Pleasure. Friends, I hope you have filled up the questionnaire that I shared with you. And over to you, Kalyan sir, for future.
Okay, sir. Once again, thank you, sir, for join us with our faculty development program, which is organized by Department of Electronics and Communication Engineering, NIT Manipur, and is sponsored by AICT ATAL Academy. So, thank you, sir, and thanks a lot, sir. This type of we are very happy. So you are giving to such type of opportunity. So you are delivering the lecture, and seriously, sir, we are proud, sir. We are proud, sir.
I'm so grateful to you, sir. Thank you so very much.
Thank you, sir. In future, sir, we are expecting your active participation, sir, with our program, sir.
I will always be available. It would be a pleasure and a privilege for me to be associated with any one of you, and of course with NIT Manipur. Of course, I look forward to that. Thank you.
Okay,
Thank you.
sir. Thank you, sir.
Thank you.
So can we
Welcome
start,
back.
sir?
Yes, sir. Please go ahead.
Okay, okay. So, ma'am,
Now,
over to you,
yes, sir.
ma'am.
Yes, sir. Now we have with us Dr. Rajesh Kumar, Associate Professor, ECE NERIST, who would talk on cognitive radio networks or in 5G. Dr. Rajesh Kumar earned his PhD in Electronics and Communication Engineering from Jamia Millia Islamia, New Delhi in 2012. He has completed Master of Engineering Science in Control Systems from NIT Patna in 2007 and BE in Electronics and Communication Engineering from Bangalore University in 2001. He has more than 19 years of teaching experience from different reputed institutes. Presently, he is an associate professor, Department of ECE Neris Nirjuli, Itanagar, Arunachal Pradesh. His research interest is including sensors, WSN, MEMS, communication systems, etc. 4 PhD degrees are awarded under his supervision. More than 65 number of research articles are published in reputed journals and conferences. He has taken many administrative responsibilities such as Head of Department ECE NERIS in 2018 till 2018, then Chairman Telephone NERIS 2017, Coordinator Institute Industry Interaction Cell NERIS 2017, Institute Coordinator for Spoken Tutorial IIT Bombay 2017. His academic achievements are organized international conference, FDP invited lectures. Over to you, sir.
Mandal sir,
Yes,
should I
sir.
start now?
Yes, sir. Yes, sir.
Okay, so first of all, I would like to thank you very much, madam, for giving such a nice introduction about me. Respected Professor Gautam Sutradhar sir, Honorable Director, NIT Manipur, Dr. Reddy Singh, Associate Professor, NIT Manipur, Dr. Kalyan Mandal sir, Assistant Professor and Coordinator of this program, faculty colleagues, delegates, speakers, and participants. A very good afternoon to one and all present in this FDP. I am very much thankful to NIT Manipur for giving me an opportunity to deliver a talk in this prestigious AICT ATAL FDP on the topic of trends of research and development in electronics and communication area. So my topic for today's talk will be on cognitive radio network in 5G. So please allow me to share my PPT so that we can start with the technical content. So, Mandal sir, kindly
sir.
please confirm whether it is visible.
Yes, sir. Yes, sir. It is visible, sir.
Thank you. So, okay. So, let me go to the introduction page. Okay. So, first of all, before going to the technical aspects, let me talk on little bit about this cognitive radio. Why we are here to talk on this cognitive radio, or what is the requirement of this cognitive radio? As we all know, the concept of cognitive radio is very much old. I mean, it is more than 20 years back that in 1990s it was started, the concept of cognitive radio. But why nowadays it become more popular and demand is more for research in cognitive radio and all? Because we all know that most of the wireless communication system are based on static channel allocation, or we can call it the fixed frequency allocation, which results in a low spectrum utilization, up to low as 15%. So that means whenever there is a spectrum distribution to the licensed user or to the primary users, they are actually utilizing it up to on an average it is 15%. I'm sorry. So nearly 85% of the resources is unutilized. So, okay, when there was no requirement of this spectrum, then it was well and good. It was kept as it is. It was lying as it is. But nowadays, what is happening, as we all are aware, previously we were using only the mobile phone, which was not even having the social media, no IP was required, and only calling can be done, right? But nowadays, what we need everything on our fingertips. Even if we are habitual like that, everything is related to IoT. Let's say switching on a geyser, on a fan, everything should be on your fingertips. That means the number of devices has been increased in a very big way. So first point, due to the more demand of the data, more demand of the spectrum, the people or researcher were forced to look into this area, that how the unutilized frequency band or channels can be utilized for the secondary users. So this is the main motive for why I've chosen this topic, cognitive radio, for today's discussion. So the concept of this cognitive radio is was started in 1999. Let me go to the slide one by one, then I will discuss this. So this one, I will just show you the contents of my presentation. I will be talking about cognitive radio, about the cognitive radio. Then, since we have to understand from where this cognitive radio has come and what we require in the future, and that all we will be talking under this topic, aware, adaptive, and CRs. Then the radio compatibilities, properties, about the spectrum awareness, about non-interference methods, dynamic spectrum access, and application side also we will just have a look of an example based on cognitive radio, WSN, and conclusion and references. So this will be the sequence for this under this session. So I was talking, okay, one more point. I have given this complete sentence wise. I should have given the points also, but I thought since this is an online interaction and sometimes voices are not clear at the reception end, and I wrote their complete sentences, what like complete explanation over there. So please bear with bear with that. So this Mr. Joseph Mitola III was given this concept of cognitive radio, and at that time it was the novel approach in wireless communication, in which the defined radio, in which this is just let me take this. Okay, just a moment. Just give me 1 minute. I was wanted to take this. Pointer, sorry. So, okay, I was talking about this Mitola model. So under this Mitola model, this is basically, this cognitive radio is the part of software defined radio platform. So now you must be thinking that why I am talking of this software defined radio platform, because before this software defined, we have two more things that I will discuss in the next two slides. So software defined means it's a fully reconfigurable wireless transceiver which automatically adapts its communication parameters to the network and user demand. So this was started in 1999. This is just an historical part I brought to you. So independent studies performed in some countries confirmed that the observation and concluded that spectrum utilization, the word I'm focusing here, the spectrum utilization depends, hello, okay, depends on time and place. So moreover, the fixed spectrum allocation prevent rarely used frequencies from being used, even when any unlicensed user would not cause noticeable interference to the assigned services. That's what I explained in the very beginning of this presentation, that the only 15% of resources is being utilized, and 85% of the frequencies that channel is unutilized into that. So here the cognitive radio concept will be utilizing unutilized frequency channels or bands. The first okay. I think Mandal sir, is there any interruption, something, or wanted to say something? No. Fine, I'm moving ahead. So the first cognitive radio wireless area network standards, that is IEEE 802.22, which was developed by a standard committee and published in 2011. And this standards gave geolocation and spectrum sensing for spectral awareness. This geolocation combines with a database of licensed transmitter in the area of area to identify available channels for use by the cognitive radio network. Now, this okay. The cognitive radio is basically a radio that can be programmed and configured dynamically to use the best wireless channels in its vicinity to avoid user interface and congestion. So it automatically detects. The beauty of this this software-defined radio or cognitive radio is that it automatically detects the available channel in wireless spectrum, and then accordingly changes its transmission or reception parameters. So automatically it detects and correct accordingly, and allow more concurrent wireless communication in a given spectrum band at one location using the dynamic spectrum management. So it is done by the system itself. So it's a very software dependent or software defined radio. So cognitive radio is a form of wireless communication. We can define this CR as it's a form of wireless communication in which a transceiver can intelligently detect which communication channel are in use or which are not. So detection is one part here. So which communication channel are in use and which are not. So it instantly moves into that vacant channel while avoiding occupied ones. If the means moving from one to another channel by sensing it, so whether it is occupied or not, if it is vacant, it moves to the another channel. So hopping can be done in the another location, another channel allocation. So it does not cause any interference to the licensed user. So this is what I will be talking later on about the cooperative and non-cooperative interference. So then, okay. Again the same, but just given in the another form, another view we can have about this cognitive radio. So it's a smart radio that are able to identify spectrum. It's able to identify spectrum for clarification, I've just written the radio frequencies that are not being used, and to quickly tweak and to quickly tune to those frequencies to transmit or receive signals, and it have a ability to instantly find other spectrum if interference is detected on frequency being used. So this is the key point also here. So it has the ability to instantly find the other spectrum if the interference is detected on the channel which is being used. It cannot adapt their own output, power output, modulation, channel plan, network protocol, etc. So dynamically to maximize throughput and minimize interference. So it maximizes the throughput and minimizes the interference. So this cognitive radio is dynamically optimized spectrum utilization through opportunistic use of all available resources. Now, this is the what which I was talking of. So here we can see this is the SDR technology continuum, how the technology has been moved from software defined about the software defined radio or soft defined radio, we can call it. A software sophistication increases the radio system capabilities, can evolve to accommodate a much broader range of awareness, adaptivity, and even the ability to learn. So here we can have a look as days increases or technology increases, we can have a look of this terminology. So we have software capable radio first at the very beginning, then improved a little bit, and then we had software programmable radio, and then software defined, and then after aware radio, adaptive radio, and cognitive radio. So nowadays we are more into this. Just a moment. Okay, I was talking of this software capable radio, software programmable radio, and software defined. So there is a minor difference here. The difference here is that here under this software capable radio, it was only the few parameters which can be interfaced with the software. The hardware was supposed to be interfaced with the hardware. Hardware was supposed to be interfaced with the software, and the system was able to interface with the programs and all. So here it was software. There are few more software capable devices or radio. I will be talking later on. We have the list of all these software capable radios, software programmable radios, and software defined radios. So when I will move to that, I will discuss in details about this. So now the similarly, in simple word, I wanted to say, so the radio under this defined software defined, the radio in which some or all the physical layer functions are software defined, then it is called as software defined radio. Here the some part which was programmable can be corrected, few things can be controlled, few things through the program, that was software programmable radio. So the day by day it was improving. Here it was only ability to just handle that that was connect to the software, that can understand the software. The hardware can interface, can communicate. Here we were having the some component or some part of it which was supposed which can be programmed, and can be utilized. Here we have that almost all the physical layer components is software defined under this. So under this only, we have the aware radio. Aware means there are three types of people in the society also. A group of people which can only aware about the things, what is going on in the society, and do nothing. So that is aware category. Adaptive, if the people are hearing something, they change themselves according to the situation which is good for them. So that is adaptive, or whatever the good thing there in the society, they adapt. So in cognitive radio, what is happening? If they want to rework on ourselves by looking into the society, by taking the good things with them and removing the bad things, so that is all about the cognitive radio. That is you are optimizing yourself, optimizing the system. So this is the basic difference between these three here. So all these three comes under this software defined radio. So moving ahead. So here you can have a look of the diagram. You can see how this technology has been improved from let's say maybe 1990s, and we are in 2022. So here the technology increases in the form of this software capable, software programmable, software defined, and cognitive radio. So here you might have, you can see the different abbreviation here. Single channel, this is PLRS, and ARC, WSC, this is under the software capable systems. So these are different radios, it is named here, and this comes under the category of software programmable devices, and this is under the software defined and cognitive radio. So in the few more slides, I have the list of all these different radios and about the functioning. I will be going in very short for this part, which I was showing. This is under that software defined radio, software capable radio. That was the first one. It is single channel ground and airborne radio system. Sync gas, that is single channel ground and airborne radio system. So here this is the family of very high frequency modulation in the range of VHF. Okay, so okay, so let me, one banner is coming. Okay, so here FM radio that provides the primary means of command and control. So it's a basically it has the singers family of the radio has the capability to transmit and receive. It is having the capability of transmit and receive voice and tactical data and record traffic of any of the 2320 channels of 25 kilohertz between 30 to 88 megahertz. So it was with the internet controller software capable, right? So here, so this system was capable of handling or with connecting or interfacing with the intercontroller. Okay, internet controller. Now the another radio system which is under the same category, PLRS, that is position location reporting system. So this is basically PLRS employs a computer control. Here is computer control crypto secured master station and an alternate master station to ensure The survivability and continuity of operation. So the network under master station management, it is being used for surveillance purpose and for detection of the position by the station master. So this position location reporting system was there. That is the type of software capable radio system. Okay, now we have NWSC. This is used in satellite communication. Here this is a demand assigned multiple access satellite communication SATCOM terminals. It meets the tight size and weight integration requirements. The single waveform radio has a computer. So a computer is connected with this radio interface and is software. It is a software capable. So these are the few examples which I was showing you. So here I will quickly go for this. This is this radio, that is AN/ARC 164. This radio is used by deployed on all US Army wing aircraft that provide anti-jam secure communication link to Joint Task Force mission in the tactical air operation band. So this is AVKIP 2. So another one, this is also used by the US Army Aviation, that is AN/ARC, having the different feature, different applications, different requirements, but that is these all are software capable. So see, anything is improving day by day. Let's say we made something, we have a primary device, and then requirement is little bit more, so improvement is done on that, so become a new definition or become a new type, and system improving day by day. So here also this is another ANVRC 99. So this was used by the National Security Agency, NSA, and this LST-5E, this is a software capable UHF tactical satellite com LOS transmitter with embedded communication security. The LST-5E provides the user with a single unit for high-grade half-duplex secure voice and data over both the wideband. The terminal is compatible with other AM or FM radios that operates in the range of this particular frequency range, 225 to 400. So this is ANPRC 6725. This is handheld or wearable tactical radio, and this multi-band inter-team radio, this is the advanced version of that SINGARS, that is the first one, that is provided voice communication between infantry soldiers. TSCL, that is combat survival or avoider locator, that provides UHF ultra high frequency range communication and location for the purpose of joint search and rescue center operations. That we can see the different applications here being used for the security purpose, for the other applications also, for the different radio and all. Here you have another type, MIDS, that is multifunction information distribution system. So here in this direct sequence spreader spectrum, frequency hopping, anti-jam radio, and supports the Link 16 protocol for 1 gigahertz. So originally called as Joint Tactical Information Distribution System. This radio waveform has redeveloped on the new hardware platform and is now being converted to a JTRS. Okay. So now I think this is we enter into the software programmable zone. I think here it is, we have this Jaguar Falcon So these all are under the category of software programmable radio. So I'll just go for this. Okay. So here you can see the example of this Jaguar PRC 116. So this is in service in more than 30 nations, including the UK and US, UK Army and US Navy. It is frequency hopping. It is a frequency hopping software programmable radio. This is a software programmable radio with considered ECCM capabilities, resisting jamming by constantly shifting offsets to unjam frequencies. The security is further heightened by use of Tremble. So Jaguar V can also be used for data transmission at a rate of 16 kbps. So it may tolerate up to 50 radio net. So each with a dozen of radios at once. So I think what I wanted to show, I wanted to give you this complete explanation to you, because we have the different sets of radio. Radio doesn't mean only the radio which we are listening AM, FM, news and songs and all. So radio means it's a communication system, maybe a system with having the processor and all the complete set. So it's a package of hardware as well as software. Okay. So these are the few more types. So I'll not elaborate much on that. So okay, so let me go for one more selective PRC 138 Falcon. So a man-pack or vehicular mounted high frequency or VHF radio set, which has the capabilities including frequency coverage of 1.6 to 60 megahertz in SSB. Okay, continuous wave AM equivalent and FM in the VHF band and 100 preset channels. So in the data mode, this offers a variety of compatible modem waveforms that allow to be integrated into the existing system architectures. So that is Falcon PRC 138. Okay, this is the examples of SDR, software defined radios. So there are three has shown here. It's a DMR, digital modular radio. So it's a full SDR capable of interoperability with tactical systems such as HF, DA, MA. Okay, so as well as the data link coverage for link 4A and link 11. So this is system specification they have given. I will just go for the name JTRS, Joint Tactical Radio System. This is another software defined radio. So it's a current radio procurement for fully SDRs. These radio systems are characterized by SCA compliance, that specific and operating environment that promotes waveform probability. So different, as per the requirement, we have the different sets of radio. SAS, that is small unit operations situational awareness system, SAS. It is developed by DARPA to establish the operational benefits of an integrated suites of advanced communication, navigation, and situational awareness technologies. So as the word has come up over there, three more types, software capable, then software programmable, and then software defined, and then we have the aware, adaptive, and cognitive radios. So here, just in one line, we try to define this, or it is defined as the radio that sense all or part of their environment are considered as aware system. So aware system, that is, awareness may drive only a simple protocol decision or may provide network information to the maintain a radio status as aware. So this is just awareness is there. awareness is there that okay, these things are, these parameters are there, this thing is happening over there. So nothing is nothing action has taken by that system, so it is just aware radio. Now another type, a radio must additionally autonomously modify its operating parameter to be considered adaptive. If it modifies its operating parameter, then it comes under adaptive system. So this may be accomplished by via a protocol or program response. So by using the protocols or program response, it can change its systems or adapt something, then it is called as adaptive. When a radio is aware, adaptive and learns, when a radio is aware, adaptive and learns, it is a CR, cognitive radio. So the only cutting edge research and demonstration example of aware, adaptive or CRs are currently available. Okay, little bit more elaborative. So you guys, if you want, you can go through this in details. I have just gathered some information about where radios, these three types of radios. So it's a voice radio. A voice radio inherently has sensitive compatibilities in both, I think this, in both audio microphone and RF receiver frequencies. Just let me keep this at side. Okay. Okay. A voice radio inherently has sensing capabilities in both audio and RF frequency. Audio means microphone and RF frequencies. When these sensors are used to gather environmental information, it becomes an aware radio. So just little bit more elaborative that when we are using the sensors that gather the environmental information, it becomes aware radio. So the local RF spectrum, may be sensed in pursuit of channel estimate, interference or signal of interest. Audio input may be used for authentication or context estimates or even natural language understanding or oral human machine interface interaction. So added sensors enables an aware radio. An added sensor enables this aware radio to gather other information such as chemical surroundings, geolocations, time of day, biometric data, and even the network quality surveys. So the key characteristics that arises a radio to be level of aware. A radio to be a level of aware is the consolidation of environmental information not required to perform simple communication. So utilization of this information is not required for the radio to be considered aware. There is no communication performance motivations for developing this class of aware radios, and it is expected that this set will be sparse. Okay, if you are only gathering the information, all the information related to signal, related to environmental hazards or the temperature or the whatever the sensor you have used. So if you are not, hello, then there is no use of that. So I mean, we need to use those information which is being gathered by those sensors. Okay, the few purposes we can use this aware radio. That a very interesting example is given here. So let's say this aware radio may provide a pull down menu of the restaurants within a user defined radius. So the radio may gather this information in the future from low power advertisement transmission and sent by the businesses to attract customers. Another one, the military applications also, they can use for this information that includes predefined set of radios and their relative positions, it can give. So for an example, the radios exchange global positioning systems coordinates in the background. So that can be shared, that can be used. Okay, so the radio is not utilizing the information, but it is aware of the situation, one example of the aware radio is the CDMA for CDMA based cellular system, which is proposed by Chen et al. This system is aware of quality of service matrices and make reservations of bandwidth to improve overall quality of service. So this is all about this aware radio. Now the adaptive radios. So if the radio makes changes to its operating parameter, such as power level, I'm indicating here the technical terms. In general, I have already explained you the what is adaptive radios and how it is being. So these operating parameters like power level, modulation, frequency, and so on, it may be considered as an adaptive radio. So okay, so little more explanation is here. So a radio that supports multiple channel bandwidths is not adaptive. A radio that supports multiple channel bandwidths is not adaptive, but a radio that changes instantaneous bandwidth, and or system timing parameters in response to the offered network load. If it is changing instantaneously its bandwidth, its parameter, then it becomes the adaptive. So then it may considered as adaptive. So but if you have the multiple channel bandwidth for a simple system, it is not adaptive. At a time, if you are sensing the parameters and offered network load and accordingly the bandwidth is changed, then it is adaptive. So if a radio that modifies intermediate frequency filters characteristics in response to the channel characteristics, it may be considered adaptive. Okay, the frequency, instantaneous bandwidth, modulation scheme, error correction, coding, channel mitigation strategies such as the equalizers or rake filters, system timing. So these are data rate, transmit power, and even filtering characteristics are operating parameters may be adapted. So these are the parameters which is given here: frequency, instantaneous bandwidth, modulation scheme, error correction coding, channel mitigation strategies, and maybe few more things which might have I have not written here, that transmit power, event filtering characteristics, etc. So a frequency hop spread spectrum radio is not considered adaptive because once programmed for a hop sequence, it is not changed. So a frequency hopping radio that changes hop pattern to reduce collision may be considered. So these are the very interesting things. If you cannot say any system which has the frequency hopping spectrum, whether it is adaptive or not. So simply it is not adaptive, not considered as adaptive. But if it is changing its hop sequence, it is changing its hop sequence as per the requirement for the reducing the number of collision, then it may be considered as adaptive. So that is the point. Okay, the few examples they have given, so I'm skipping that. So although this is the adaptive modulation implementation 802.11, generally are the dedicated purpose fixed application specific integrated circuit chips, not software defined, and thus is not normally considered adaptive. Okay. That's all. That was about adaptive radios. Now coming to the, again I will come to this cognitive radios. So this cognitive radio has the following characteristics. This is little bit elaborative. I'm sorry. A CR that has the following characteristics: sensors creating awareness of the environment, actuators to interact. So what are the components here? That sensors that is creating the awareness of the environment, actuators that to interact with the environment, a model of the environment that includes state of memory, a state or memory of observed events, a learning capabilities that helps to select specific action or adaptation to reach a performance goal, and some degree of autonomy in action. So this is the following characteristics means the functioning here it is shown, the sensor which is creating awareness, the actuators which interacts with the environment, a model of the environment that includes the state of observed events, and then you have the learning capability that helps to select a specific action in that situation, what action has to be taken, or adaptation to reach a performance goal. Since this level of sophisticated behavior may be a little unpredictable in early deployments, okay, and the consequences of misbehavior are higher, so the regulators will want regulators will want to constrain a CR. So obvious, there will be some constraints also. There will be some regulatory body also for that. So a most popular suggestion to date for this constraint is a regulatory policy. So obvious, there will be a regulatory policy engine that has machine readable and interpretable policies. So the machine readable policies controlled radios are attractive for several reasons. One feature is that ability to try out a policy and assess it for impacts. So the development may be controlled to a few radios on an experimental basis. So it is possible to access the observation and measurements of the behaviors if the result is undesirable. So the policies may be removed quickly. This encourages rapid decision by regulatory organization. So this is policy driven, okay, approach is an attractive because especially variant or even temporarily variant regulations may be deployed. For an example, when a radio is used in one country, when a radio is used in one country and it is let's say it is a new country, the policy may be reloaded to comply in the new jurisdiction. So also it's a band is if a band is available for use during a certain period but not during another machine which is readable, policy can realize that behavior. So the language being used to describe the CR is based on assumptions of a smart agent model. So with the following capabilities, so these are the capabilities written in the bullets here. Sensors creating the awareness in the environment, the actuators enabling interaction with the environment, memory and a model of the environment, learning and modeling of a specific beneficial adaptation, the specific performance goals, autonomy, constraint by the policy. So these are the things to be done over there. These are the following capabilities in that. Okay, so these radio senses the spectrum environment, identify the unoccupied portions. Okay, so here you can see the differences, the points which is mentioned here. This is the comparison of radio compatibilities and properties. So you can see the different parameters here. Frequency hopping, which is in the all the systems, it's software capable radio, software programmable radio, software defined radios, aware radios, all these types. It is available, the frequency hopping. Then automatic link establishment. These are the radio properties. The channel selection, which you are talking of, yes, it is available to all. So programmable crypto, yes, it is there in the all these 6 categories. Networking capabilities, it was not there in the capable radios. It was starting from this software programmable radio. Then you have the multiple waveform interpretability. So again, it is not in software capable radio. It was started from software programmable radio and then after. So in the field upgradable, again the same. So here you can see at this point full software control of all signal processing, crypto and networking functionality. It was not there in the software programmable radio. It starts from software defined radio. Here you can see the stars here. Just have a look of this. The industry standard organizations are in the process of determining the details of what properties should be expected of aware, adaptive and CRs. That's what it is marked, but it is there available. Quality of service. Quality of service, it was measurement was not there in all these 3 categories. So here it is starting from aware, adaptive and cognitive. So channel state information actually it was there in these 3 categories. So modification of radio parameters as a function of sensor end. So again you see this modification of radio parameters as a function of sensor input. So it is not even in aware radios also there. It is there with the adaptive and cognitive. Learning about the environment, that is only cognitive radio. Experimenting with different settings, that is cognitive radio. So this is the overall comparison of radio compatibilities and properties. Okay, so moving ahead. Now coming to the types of cognitive radio. Types of cognitive radio, if I talk of. Now, depending, this is category is based on in which category, how you are on the what is the basis of categorization. Okay, so if I talk of, basically it is categorized on the basis of the transmission and reception parameters. Transmission and reception parameters. Oh, it is there. So there are 2 main types. Full cognitive radio, which is Mitola radio, that is in which every possible parameter is observable by the wireless node or network is considered. So all the parameters is considered under this full cognitive. But in this spectrum sensing cognitive radio, only radio frequency spectrum is considered. Okay, so here the parameter will be only radio frequency spectrum. So other types of dependent on the part of a spectrum available for cognitive radio, that is here the okay, the term is coming here, the spectrum sensing cognitive radio. So I would like to just the spectrum sensing, this is used to diagnose the availability of frequency resources. Okay, this is used for to diagnose the availability of frequency resources. So this is depending on the transmission and reception parameter. Now, if you talk of CR performs complete dynamic spectrum allocations, here the licensed one. Okay, the primary user and secondary user is defined in this category here. This licensed band cognitive radio is capable of using band assigned to the licensed user. This except for unlicensed band such as UNII band or the ISM band 2.4 gigahertz, which we all know. Working group is developing a standard or wireless regional area network which will operate on unused television channel, also known as TV white space. Okay, so which can be this another one unlicensed one, that is which can be only utilize unlicensed part of the radio frequency spectrum. One such system is described in the IEEE 802.15 task scope specification, which focus on the coexistence of IEEE 802.11 or Bluetooth. So okay, so here the TV spectrum which is mentioned over there, the TV band devices are unlicensed radio frequency, and it is operating in a vacant channels, that is maybe 54 to 698 megahertz. So if you talk of in VHF, it is 54 to 216 megahertz. In UHF, it is 470 to 890 megahertz. Okay. Okay. I will go for a few more types, and then I will just come back to this spectrum holes, white space and all. So okay, the spectrum word is coming here very quickly, so we'll go for it. This spectrum mobility, the process by which a cognitive radio user changes its frequency of operation. Cognitive radio networks aim in use to spectrum in a dynamic manner by allowing the radio terminals to operate in the best available frequency band, maintaining seamless communication requirements during transition to better spectrum. So these are the types of CRs only where you have the different specific things is happening over there, that spectrum mobility, spectrum sharing, spectrum based sensing based spectrum sharing, database enabled spectrum sharing is there. So this under this spectrum mobility, the process by which a cognitive radio user changes its frequency of operation. If it is changing its frequency of operation, the cognitive radio networks aim to use of spectrum in a dynamic manner by allowing radio terminals to operate. So spectrum sharing cognitive radio network allows the cognitive radio user to share the spectrum bands of a licensed band user. However, the cognitive radio user have to restrict their transmit power, and so that the interference caused to the licensed band user is kept below the certain threshold. So this I was talking of this spectrum sharing only. So spectrum sharing is okay. I will talk of these two in the next part. I will just say this spectrum sensing classification and all. So see, I will just go back to that slide. Before that, I will just would like to show you the spectrum sensing. This is the general model of a spectrum sensing. The received signal is there. A spectrum sensing technology is being used, and then you have the threshold comparison, and then the sensing decision is being taken. So there are different types of spectrum sensing. Classification is here. This is basically categorized as two types: cooperative sensing and non-cooperative. So under this non-cooperative, you have nothing. This is the local sensing, and you have nothing to do much into it. So what is happening? Say if you are sensing and at a particular frequency at a particular rate, or you're just checking whether this band is channel is vacant, occupied or not. So this is non-cooperative. Simple steps you are doing. you are not collaborating or taking help from your neighboring nodes. So that is non-cooperative sensing. So if you are taking help and taking the collective decision from the nodes, then it is called under this cooperative sensing. So taking help or taking help from the nodes or taking a collective decision, maybe that nodes or distribution, that may be the distributed sensing, or it may be the centralized sensing. So that is the way of classification for the spectrum sensing. Now we have the different techniques for spectrum sensing. That is called as energy detection spectrum sensing, autocorrelation based detections, matched filter based detections, Euclidean distance based detections, or wavelet detections. Okay, so these are the types. I will go later on this topic. So now I'm coming back here. So there are, again, I'm just elaborating more on this because this is the main point for this technical aspects which I'm talking of. Achha, since I'm here on the topic of cooperative, non-cooperative, so some smart radio using the concept of cooperative diversity. So we all know the diversity is what? Diversity is the method for improving the reliability of message signal by using two or more channel with different characteristics. It is used for combating fading and co-channel interference. So that is all about the diversity. Diversity is the method for improving the reliability of the message signal by using two or more channels with different characteristics, and it is used for combating fading and co-channel interference. Co-channel interference, fading means fading may be happening due to the multipath propagation and all. So that can be defined in terms of diversity. So here the cooperative diversity is a cooperative multiple antenna techniques for improving or maximizing total network channel capacity. So as we all know, it is not here on the slide. I'm just explaining the things. There are three types of systems. That is direct scheme, non-cooperative schemes, and cooperative schemes. Okay. So this under this direct scheme, we have the system is the decoder decodes the data using signal received from source on the first phase. Okay, so in non-cooperative scheme, the destination decodes the data using the signal received from the relay and the second phase relay on the second phase, which results in signal power boosting gain, and there is no increase in the diversity order. So increasing, if the diversity order is increased, means it is better, it is improved system, quality of service is improved, right? So under this cooperative scheme, the destination node combines two signals. Received from the source and relay, nodes, which results in diversity advantage. So degree of diversity may be increased, and that means the quality of service will increase. So there are three schemes. So this will be coming under the adaptive one. So the selected one of the three model as an adaptive. Now one more point which I wanted to discuss. So here there are there are prototypes of CR can be distinguished according to the possibilities of coexistence of secondary user and primary user in the channel. So now I was talking of this, just a moment, 1 second. Okay. So CR classification, two categories I just explained, that one is licensed one and another one is unlicensed one. So licensed and unlicensed one means, if it's a licensed one, you call it as primary user, and if it's a unlicensed user one, that is called as secondary user. So what should be the relation if you want to utilize the channel of licensed user? What should be the condition? What should be the situation over there? So primary user can access the spectrum. Primary user can access the spectrum whenever they want. Whenever they want, they can use their spectrum, while the secondary user are restricted by the primary user. That is, the secondary user should respect primary user's quality of service and interference coming from secondary unit to primary unit. So these two things has to be taken care. Secondary user should respect primary user's quality of service and interference coming from secondary user to the primary user. Now I was talking of what are the different conditions or different access may be there. So there are three types of access. There are three types of access. One is called as underlay access, and then overlay access, and then interweave access. So these three types of access that I will be discussing one by one. So if under delay access, if the secondary unit if the secondary user may transmit simultaneously with the primary user over the same channel, however, the transmitted power of secondary user should not exceed a certain threshold. So this is why the certain threshold, because if you increase that certain threshold, the chances of interference will be there. So to keep the interference on primary user below that reliable values or tolerable values, we can call it, to keep the primary user interference below tolerable values, we set up a threshold level over there. So underlay access is what? The secondary user may transmit simultaneously with the primary user over the same channel, but transmitted power of secondary user should not exceed a certain threshold. Certain threshold means interference due to the tolerable value of the primary user should be taken care. In overlay access, secondary user may transmit simultaneously with the primary user on the same channel up to its maximum power, but at the cost of playing a role of relay between two or more primary users. So it can send the data with the maximum power using relay. So this kind of access requires high level of cooperation over there. So the point is here, you can send your data with the full maximum power, but you will be working there as a relay over there, and you should have the high level of cooperation with the primary users. The secondary users should have the high level of cooperation with the primary users. The third category, which is interweave access, secondary user is allowed to transmit using its maximum power only when primary user is absent. If the primary user is absent, then you can use secondary user can use the maximum power and can transmit the signals. So it is also known as classical CR. So this is out of these three, an underlay access that you can send it simultaneously but keeping the power low below a threshold value. Overlay access, you can send it, but here the secondary user will be treated as treated as a relay, and it should have the high cooperation with the primary user. And the third one, which is the classical one, that is if there is no primary user is absent in that channel, okay, go with the maximum power. So that is all about this access. Now, if you talk of the cognitive radio technology or technical aspects, you will be again, I will discuss in the next slide. So before that, under this interweave, there are two types, which I call it that classical CR, classical cognitive radio. So two types means we already know about this half duplex, full duplex, and all. So there are only two categories: half duplex CR and full duplex CR. So what is happening here in this secondary user activity period is basically divided into two slots. One is sensing, first part is sensing, second part is transmitting. So the half duplex CR, that is also denoted as noted as HDCR, half duplex CR, cognitive radio. So what is we already know that this will be one-way communication, half duplex. The only either you can during sensing slot we can only sense and channel to detect the presence of or present or absent. That can be done under the sensing part. If present, secondary user will okay, if the primary user is present, secondary user will be silent in that case. So under this half duplex cognitive radio, HDCR, it listen before talk, like walkie-talkie, or we can the system hello alpha, then from other side it is coming, okay, proceed, then only you start talking. You finish your talking, then reply will come from that side. It cannot be both way communication at the time. So that is half duplex over there. So during the sensing slot, what it does, only senses and channel to detect, and detecting the channels to whether it is present or absence of for which we are detecting, for the primary user, whether the primary user is present or not, because under this interweave system, you can only send the data with the maximum power, you can only transmit the data with the maximum power if the primary user is absent. So that means you have to sense whether the primary user is absent there or present there. So if it is present, secondary user will just be quiet over there, will be silent. Otherwise it will be resume sending data, it will be resume sending the data. And this will be, let's say primary user is present over there, then what it will do, the sensing part, what it will do, it will keep sensing. It will not send the transmission will not be happening over there. It will periodically will sense the path, and then whenever it finds that okay, now the primary user is absent over there, can transmit, and then it will go for the transmission part. So now in full duplex here, what will be happening? two peers can use the same frequency. Two peers can use the same frequency for to transmit or receive simultaneously using the concept of self-interference cancellation according to the signal of interest. It is also called a in-band full duplex, right? So two peers can use the same frequency to transmit or receive simultaneously using the concept of self-interference cancellation according to signal of interest. So it is also called as in-band full duplex cognitive radio. So that was the concept of this sensing and all different X's and all. So now moving ahead, so I was there at the sensing based spectrum sharing. So in sensing based spectrum sharing, cognitive radio networks, cognitive radio users first listen to the spectrum allocation to the licensed user to detect the state of licensed users. Based on the detection result, cognitive radio user decides their transmission strategies. So if the licensed user are not using the bands, cognitive radio user will transmit over those bands. So that's what already I discussed this. So database enabled spectrum sharing. In this modality, spectrum sharing cognitive radio user are required to access a white space database prior to be allowed or denied or access to the shared spectrum. So as the word came here, the white space database. So what is white space or what is the spectrum holes? So see, if you are having, if the frequency which is not being used, the free frequency bands that are called spectrum holes. Okay, the free spectrum band which is not being used is called as spectrum holes or white space over there. So right, so the white space database contains algo, mathematical models and logical local regulations to predict the spectrum utilization in a geographical area and to infer on the risk of interference posed on incumbent services by a cognitive radio user accessing the shared spectrum. Okay. Now coming to the technology part side little bit. So although the cognitive radio was initially thought of as software defined radio extension, now focuses on spectrum sensing cognitive radio. The chief problem in the spectrum sensing cognitive radio is designing high quality spectrum sensing device and algo for exchanging spectrum sensing data between the nodes. So researchers are working on this, and there are many more new things has come up on this, that designing high quality spectrum sensing devices. So it has been shown that a simple energy detector cannot guarantee the accurate detection of signal presence, calling for more sophisticated spectrum sensing techniques and requiring information about the spectrum sensing to be regularly exchanged between the nodes. Increasing the number of cooperating sensing nodes decreased by the probability of false detection. Filling free RF bands adaptively using the OFDMA, which is a possible approach. Another proposal was a spectral pooling system in which free band were immediately filled by OFDMA subbands.
Excuse me, sir.
Yes.
Yeah, sir, how to be analyze unutilized band?
Okay, so that's what I was talking of spectrum sensing. So I already explained this. There are, okay, I'm going to that side only. Okay, let me go to again. So you can see this. These are the techniques for spectrum sensing. So either you can use, there are 4-5 techniques. I have mentioned here for 4 types: energy detection, or autocorrelation based detection, match filter based detections, or Euclidean based distance based detections. You can use these models and can find out the white space or the spectrum modes.
Sir, currently any use, practically use for this cognitive radio currently?
Yes, yes. I think at very beginning I have just mentioned this spectrum sensing, or finding the space, finding the unused, unallocated spectrum, which is the requirement for the 5G, fifth generation mobile communication systems. Because the number of users, number of systems is increased rapidly. Okay, let me go to the one more slides I have. Just I will go for it. Then I will come back. Say if you see this, the challenging scenario for under this 5G. See this, the user experience data rate what we require. The minimum, this is the minimum achievable data rate for the user. That is, you require user experience data, connection density, end-to-end latency, traffic volume. All these mobility and peak data rate is required for fifth generation. So here, what you require? You require a user experience data rate, maybe from up to 1 gigabits per second. Connection density will be reaching to this level, 100 million connections per kilometer. So end-to-end latency, right? So these are the requirements actually. That's what I'm showing this.
Okay,
These
sir.
are
Thank you.
Thank
you.
Okay, fine. So I will be going to this part. So here, the layered cognitive approach is spectrum sensing, spatial processing. Here in spectrum sensing, using the interference-based detections of transmitters. Under this special processing, MIMO technologies allows resistance to the interferers, optimize the signal to noise ratio in multiple antenna processing. Spectrum sensing, which is able to operate in crowd shared spectrum, detect interferers, mitigate them, and avoid them by changing operating parameters or frequencies. Spectrum management, this capture the most available spectrum terminals and base station that can change the operating frequency dynamically. So spectrum mobility, use the spectrum dynamically. Mobile user stations and the base station can decide to change the band where they operate. This is just an spectrum subleasing sequence is shown. For one, motivation for CRs is the potential income stream derived from subleasing idle spectrum on a non-interference basis. So whatever I have explained, this is flow diagram, we call it, or an approach is shown here. Subscriber 1, subscriber 2, these are service provider, public sector. So when call is being done from here, that subscriber 1 to the service provider, it connects to the subscriber 2, and then subscriber 2 respond to the service provider. Subscriber 1 can talk with subscriber 2 on the usual channel. So subscriber running out of channel, then subscriber provider request subleasing of this public spectrum manager. So it is given to the subleasing and then again it is allotted from here. This is a periodic handshake confirming sublease. So service provider commands channel changes on sublease termination. So this is being acknowledged, and then billing record is set. This is just a diagram for this cognitive radio cycle and dynamic spectrum access. So this is by the diagram we tried. This is authors were tried to show this spectrum access. This part already I have discussed. Is moving. So here these models you can just refer to the few literatures. You will be finding the mathematical model and all. But basic thing is based on the energy detections. Here you can see you convert this and then find the average, again comparing with the threshold values, and you are getting this. You will be finding that spectrum over there based on the energy or energy signal to noise ratio, autocorrelation based on Euclidean distance. These are the basis by which we can find out the space of a spectrum or white space over there available or not. So now the CR use case of geological, several interaction between the CRs and the world are enabled and are required by the geological informations. So there are, it is geological specifications. So user is connected, GPS satellites, space and time aware, scheduling of tasks, boundary aware policy deployment, aware routing, variant advertiser. So these are the okay. So here again you can see the non-interference method of dynamic spectrum access. Different strategies for deploying the non-interfering waveforms have been proposed. So this is I have taken from some paper, is referred over there. So see this schemes you can see from 1 to 5, moving frequency like this, and then 2 adapt bandwidth and frequency, adapting bandwidth and frequency, and then here this is dynamic OFDM, then dynamic direct spread spectrum, and then this is frequency hop spread spectrum is shown here, right? Okay, so okay, this is just shown as where it is being used. The cognitive radio concept of cognitive radio is very much important, because you can just see the network comparison also. The high data rate, yes, the cognitive radio, this is given with respect to LTE, 3G and WiMAX. We may have the one more table for 4G also, but that is not available here. I was unable to find the data for related to that 4G. 4G means about to this edge of this 5G. So okay, talking of LTE, 3G and WiMAX, so different network comparison. If you compare this, the high data rate, yes, under this CRs and LTE, you have the WiMAX also, you have the high data rate, but for 3G, no, it was not there. So interference resistance, yes, CR is having interference resistance, and other these networks, that is WiMAX, 3G, LTE is not having the interference resistance. So CR designed for interference rejections. Okay, all IP, yes, IP based this CRs, LTE and WiMAX, not 3G. So self-configuring, this is CRs is, you can just see all these parameters where S is mentioned, this is under this CR. So I will just go for these topics, these points. properties or which we are comparing. Self-configuration, yes, it is there in CR. Designed for voice or data, yes, but dynamically selected spectrum, yes. Operates in free unlicensed spectrum. Cognitive operation, yes. Simplified RF engineering, yes. MIMO, yes, it is there. So self-organizing aerial layer. This is just an I wanted to show the use of this CR. The network dynamic channel planning will instantly form and adjust to the environment, allowing cognitive radios to adapt and connect to the best possible spectrum with maximum bandwidth. So the system will not interfere with the licensed network, can be made to operate on 700 megahertz. This is just an aerial view is shown. So these are the key benefits. The self-frequency planning. The system comes up automatically and finds available frequencies. No manual frequency coordination required. Self-optimizing. The system uses dynamic spectrum access technology to maximize throughput and reliability, delivering a licensed spectrum experience in unlicensed spectrum. Leverage existing smartphones, laptops, tablets, etc., directly into the XMAX phone mobile radio network to save cost and offer unmatched applications and functionality. End-to-end IP architecture, simplified integration with LTE, P25 and other network by industry standard interface and protocol. Tactical and scalable deployments. Yes, rapidly deployable size and weight, difficult to jam or hack. Okay, now this with respect to the application side related to the wireless sensor network. So the cognitive radio wireless sensor network is one of the candidate area where the cognitive techniques can be used for opportunistic spectrum access. So communication in wireless sensor networks consists of hundreds of wireless sensor nodes, which is deployed through the sensor field. And the distance between two neighboring wireless sensor nodes is generally limited to a few meters. Okay, so a sync node and or base station is responsible for collecting. Here it is. This may be the base station will be collecting the data from the nodes in a single or multiple hop manner, and the sync node then sends the collected data to the user via gateway, often using the internet or by other communication channel. So this is the scenario of the conventional wireless sensor network using the concept of cognitive radio. So in short, it is also denoted as CRWSN or CRSN. So typical cognitive radio sensor network CRSN architecture is shown here. So example of CRSN deployment in licensed spectrum environment. The advantages of using CR in WSN is a new paradigm of in a wireless sensor network arena that utilizes the spectrum resource efficiently for bursty traffic. So the system has the capability of packet loss reduction, power waste reduction, high degree of buffer management, and has better communication quality. So these are the advantages. The system has the capability of packet loss reduction, power waste reduction, high degree of buffer management, and have better communication quality. If the same given in different points, the efficient spectrum utilization and space for new technologies, multiple channel utilization, energy efficient, global operability, application specific spectrum band utilization, financial advantage to the incumbents by the renting or leasing, avoiding attacks. applications used in military or public security, healthcare, home appliances, real-time surveillance, transportation. Challenges. There are detection, false alarm. Obvious, if you use the sensors, sometimes you may get the false alarm also. Misdetection probability. Is there hardware, fault tolerance, clustering, scalability, topology change, manufacturing cost? These are the challenges or CRWation. This is one of the product. It is shown as XMAX wireless network. Okay, so then after, I think this is already the cognitive part. I have almost whatever was available with me, I already discussed. And coming to the little bit this, the question was why we are discussing cognitive radio nowadays. Is there any use of it? Yes, the concept is being utilized to find the spectrum, to find the space, wide to space, in the unutilized channel on the primary users, with the primary users. So this, you can see the demands actually just shown evolution of mobile networks. It is a 1G to 5G, the smartwatch, automated house, robotics, IoT, everything on the fingertips, which I already explained. Here the one just for to have is shown where we are right now. We need everything, goggles, watches, rings, everything should be wearable devices, having the wearable devices. We are surrounded by the IoTs and this type of devices. So that, which I was talking of, there is an explosive growth in the traffic, and the global data traffic will increase by more than 200 times. Okay, about 200 times was moved from 10 to 20, and about to 20,000 times from 20 to 30. Sorry, 10 to 30. So the great increase in device in connection. So smartphones are expected to remain as the main personal devices. The number of other kind of devices includes wearable devices, MTC devices, will continuously increase. The continuous emergence of new services, for example, service from enterprise and vertical industries from the internet companies will be exploited. This is already I have shown. You can see the challenges over there. User experience, connection density, end-to-end latency, traffic volume density, mobility, peak data rate in the different scenario. Like in the office, you have the clustering of the people who are there. So you might be having the high volume density over there. So in the city, dense residence, stadium, open air gathering, million connections per kilometers. So this all has to be higher speed, latency is there, mobility is very high for more than 500 kilometers. We'll be changing the stations. So these are the challenges which is being taken care under this development of fifth generation network. So this is already I have explained the user traffic, user experience data rate, traffic volume density, peak data rate, connection density, end-to-end latency, and mobility. The requirement of blooming flowers that is showing actually where we are right now and where we will reach, and what will be the requirement of the future. Sustainability of 5G. The several problems are anticipated if the today's network are used to handle the explosive development of mobile internet and IoT as follows. So these energy efficiency level, overall cost per bit, and the complexity of network deployment and maintenance cannot effectively handle the 1,000 times traffic growth and a massive amount of connected device in the future next decade. So coexistence of multiple radio access technologies causes increased complexity and degrade user experience. So these are the sustainability. Widely distributed and fragmented spectrum will cause interference. So okay. So the efficiency requirements for 5G, the spectrum efficiency should be more than 3 to 5 times. Energy efficiency should be 100 times more. cost efficiency should be 100 times. So here the spectrum efficiency which we are talking in terms of the data throughput per unit of a spectrum, resource per cell, energy, it is number of bits that can be transmitted per joule energy, the number of bits that can be transmitted per unit cost. Okay, so challenges I have already explained. So these are the technologies and spectrum requirements of 5G, the novel multiple access such as SCMA, sparse code multiple access, MUSA, multi-user shared access, PDMA, pattern division multiple access, RSMA, resource spread multiple access. This kind of technologies can increase the spectrum efficiency, user experience, data rate, system capacity, and connection density. Now the new waveforms like filtered OFDM, universal filtered multi-carrier, window OFDM, and so forth to maximize the spectrum utilization. So massive MIMO is also useful to increase the spectrum efficiency, user experience, data rate, and system capacity. So new channels coding such as polar code and LEPC, low density parity check code to increase the spectrum efficiency. Software defined air interface and end-to-end network slicing increases system flexibility to support all kind of services to enhance the overall cost efficiency. These are the few pictures for enhancing mobile broadband. Okay, this is what we require: the extreme throughput, ultra low latency, uniform experience, power efficient, low complexity, high reliability, ultra low latency, the simultaneous connectivity of 4G, 5G, and Wi-Fi across the world. We require multi-mode, multi-connectivity essentials to 5G success. So now coming to the conclusion part, this radio evolution has taken the path towards more digital realization and more software compatibility. The original introduction of the software made possible software capable radios that communicates and process signal digitally. In the pursuit of flexibility, software programmable radios and even more flexible SDRs have become the standard in the military arena and are starting to gain favor in the commercial world. We are now seeing the emergence of aware radios, adaptive radios, and finally CRs, and we have traced the continuum among these various degree of capabilities. Numerous technologies have matured to the point where CR applications are possible and even attractive. The ability of geolocate a system, sense, and spectrum known the time and date, sense biometric characteristics of people, access new software capabilities, determine new regulatory environment, are all working together to enable CRs. Knowledge of time has been available for many forms, but the integration into the broader range of full function capabilities will enable all new applications. Stable time knowledge enables a CR to plan and execute with a more precision. Using the capabilities for non-infrastructure based geolocation, dynamic spectrum access, or artificial intelligence planning is for the near term CR functions. A smart agent model for CR is attractive. So these are the conclusions. These are few references I have taken. So thank you. If you have any queries, please go ahead.
Dear participants, if have you any query, please ask to our expert is available right now.
Good evening, sir.
Good evening.
Hello. Hello. Rakesh, sir, good evening. There are some network issues there. I'm
Hello,
not
sir.
getting the voice from you. Hello, sir. Hello.
Yes, yes, you are audible. Please ask
Okay,
your
okay.
question.
Okay, okay. Sir, the question is that I am working in the RF and microwave domain, and that topic is the cognitive radio. Uh, that I want to implement this technique into the designing of the antenna. So, is there any kind of a software required to control the different characteristics of the antenna with the help of the cognitive radio technology, or we have to design the hardware and implement those and design, fabricate those design and check it by internet analyzer? And that is my question, sir.
Rajesh sir, hello. Okay, please write your question on chat box.
Okay, sir. Okay, sir. Okay. Thus, one of the question that I want to ask is that I'm
Yes.
working in RF and microwave domain, and I want to connect that cognitive technologies with that domain. So to perform to generate any technology with the hybrid of these two, I have to go through any software device, or the hardware is sufficient to implement the new one.
I think software is available based on this for the spectrum sensing and all. We can, I think, we can use the software like I forget the name, but we have the available software related to that.
So first we have to use the software to control the parameters, then we have to go for the hardware implementation.
Yes, sir. Yes, sir.
Okay, sir. Okay, sir. So that's why I am asking that if.
Yes, it is available. Yeah.
Okay. Thank you.
Okay, sir. Another question is rising from Deepak Kumar Badik. What are the disadvantages of cognitive radio network?
Okay. So see this. There is always a scope of disadvantage. Every system is any system which we are using or which we are developing is not perfect. So disadvantage we can talk in terms of we need to use like if you do the spectrum sensing and all like in non-cooperative, you need to use means power wastage will be there. You have to always knock for the searching, means you have to, you are utilizing that spectrum. And also the cognitive radio is that you cannot go for the very high number of nodes if you want to go for the in a particular area or in a particular. I think I'm audible, sir. I'm getting voice very, very, very disconnected type.
Yes, sir. Your voice is clear. No problem.
Okay, okay.
Yes, sir.
So that is the disadvantage. Till now I know the advantage only of the cognitive radio. Okay, I will look into this part. There may be some disadvantage also, but in my opinion, these are the few disadvantages which may be there in the cognitive radio.
Only power consumption or anything else?
Power consumption and the number of nodes limitations, regulatory bodies constraints that may be there.
Okay, sir. Can you share PPT?
Want to see the PPT?
Yes, sir.
Okay.
No, sir, not here, sir. We want the PPT.
Oh, okay, that we will share. That I think I will share through Mandal, sir.
Okay, sir.
Okay, sir. After collecting from you, so I will share to all the
Sure,
participants.
sure. Sure, sure.
Okay, sir. I think there is no more question. Thank you, sir, for your very good lecture or wonderful session on the topic of cognitive radio system and their evolution, their working principle, the spectrum and drawbacks, and how we can use in wireless system different purposes. So thank you, sir, for explaining with details on this cognitive radio system and their networks. So thank you, sir, for joining us.
Thank you, Mandal, sir.
Yes,
And
sir.
thank you for giving me this opportunity. And thank you all the participants. Thank you very much for bearing with me with patiently for I think 41 hour 45 minutes, maybe more.
Sir.
Thank you all. Thank you, Vivek Kalyan, sir.
Okay, sir. Thank you
Can
very
I?
much. Sir, one question is rising, I think.
Sir, one question. Sir, you are giving the example of how cognitive is used in 5G, and that in the mobile system. But is there any use in others, in biomedical application or in
say
multiple
whatever.
systems?
Whatever the devices we are using, this is an approach of how a system is self-defined and how the different nodes may be the biological system, may be the any system which is giving the information, which is giving the data to that particular network. So that is the aspect. There are 2-3 aspects you see, which I have shown you. That one, I think, SDR and SPR, all these radios, you might have seen there are different applications. So this cognitive radio can be used for different applications in different ways. So here I talked of in 5G with respect to the frequency spectrum sensing and all, and finding the more space into it or utilization of that vital space. Now, if you want to use this in the as a sensor node or for the biomedical applications, the information of those biomedical applications can be shared through the network and can be utilized by using this cognitive radio networks.
Okay, sir. Thank you, sir. Thank you very much.
Okay, sir. Thank you, sir.
Thank you, sir.
तो
Thank
सर
you,
फिर मिलेंगे सर.
जरूर मिलेंगे. Thank you.
Thank you very much, sir.
Bye, sir.